Welcome to the Python 3 Mastery course, where you will learn how to create real-world Python applications from scratch. So, why should you learn Python? Python is one of the fastest growing programming languages on the planet. Even compared to other popular languages, Python is way ahead. It is also projected to be one of the most popular programming languages way into the future. It doesn't matter whether you want to focus on web applications, games, machine learning or data science, Python is used everywhere. So, who is this course for? This course is designed for beginners with no programming experience. It is also a good match for people with some experience in another programming language. But even if you already know basics of Python, you can learn Python even more with this course. So what you can find inside the course? Let's see. In the beginning, we will install everything we need in order to run Python programs. Then, you will learn all the important concepts of programming, like variables, conditions, functions, and so much more. We also cover object-oriented programming, improve your problem-solving skills on simple algorithms, create graphical user interface with tkinter, and finally, we will create some real-world applications like text editor or simple graphical editor. We have over 80 high-quality video lectures combined with articles and quizzes so that you can test your Python skills. And if you don't understand something or if you need help with something, you can always reach out to me. Mostly, I respond within a day. At the end of this course, you will get a certificate of completion that you can put on resume or on your LinkedIn profile. The course comes with amazing 30-day money-back guarantee, so you can try the course risk-free. So do you want to learn Python? Enroll today and I'll see you in the course. First of all, I want to ask you to introduce yourself in the Q&A section. Just tell me where are you from and why you enrolled in this course. I would like to get to know you and provide a great learning experience. Well, hello guys and welcome to this lecture. In this lecture, we will install the Python on your device because in order to create Python program, you need to have Python. So go to python.org, or I will just put the link in the resource, and in here go to downloads, and in here click on your platform. I'm on Windows, so I will pick this Windows. If you are on Mac, you obviously want to click on Mac. Okay, and as you can see, there are a lot of versions, right? You can download a lot of versions, but we will go with the newest one, which was released in 2018, so actually a year before, but never mind. In here, I will simply download the executable installer. So click on that and this will download a file for you. Right now, you have a choice. You can either install everything that includes the idle, the documentation and stuff like that, or you can customize the installation and you can basically pick what you want to install, right? So that's up to you, which one do you choose. But if you are a new user, I recommend going with the install now. Okay, so click on that. And as you can see, the Python will start to install. And I will see you on the other side. Alright guys, and eventually the Python should be installed on your device, so cool. Now, it says disable path length limit. So you have something called path in your global variable environment in Windows. You don't need to worry about it. Simply click on this one and then it will ask you to kind of confirm the change. And you will click yes. And that's it. That's all you gotta do. Alright. So yeah, right now we can close the install wizard and yeah. Okay, so I got here open the Visual Studio Code, and right now we are going to install the extensions so that we can debug and like do a formatting of our code and stuff like that. Okay, so in here go to this kind of icon, okay, and as you can see it says extensions, and inside here type Python like this, and there should be a Python by Microsoft. Okay, So simple click on this install. You can either click in here and then click on install, and while we are installing in here, you can go through all the cool stuff that this extension does, right? So even there's even like video examples, right? So there's a suggestions, right? So as you type, it will automatically suggest you what you might want to use, right? And it's also support debugging. I'm not sure whether you know right now what debugging is, but it's basically when you run your program, you can step it out, right? So you can stop the program at some point when it's used when you have some bug in your code, and that's why it's called debugging, by the way. But it's used when you have some bug in your code and you want to figure out where's the problem, right? Then you want to stop the application at some point, right, where the problem occurs, and you want to figure out what have you done wrong, okay? So we will get to it later on. And there's a lot of things in here, right? So you definitely want to install, and once you install this, you need to reload it. So click on this reload button, and once you click on that button, it will basically take you to this page, and you have the extension installed, right? When you have the disable and uninstall button, everything is fine. So yeah, that's pretty much it for this lecture. Hello guys, welcome to this lecture. In this lecture we will create the first Python file, so let's get into it. Simply click on this new file in here and then type, let's say, hello.py, okay? So like this. And this will basically create a new file. It's the same as like some text file or something like that, right? So nothing too interesting. But what we will do is add some functionality. So we will define a message, and that message will be equal to hello world, and we will print the message out, okay? So on the next line I will simply write in here print, and in here I will pass the message, okay? So as you can see, the extension that we installed previously kind of tells me that I probably want to add the message variable that I defined in here, and it tells me that it is a string. But yeah, don't worry too much about it. Okay, once you write the program, we would like to run the program, right? So we would like to execute the program. And in order to do that, we can simply click by right button on our mouse in somewhere in here, and then select this run Python file in terminal. So when you click on that, as you can see, in here appears hello world. So that's basically our message, right? So what did we do? Well, we said, okay, this message will be called hello world, and we want to print the message. And when we refer to the message in here, it will basically take this stuff and put it in here, okay? So cool, that's pretty much it for this lecture. Okay guys, in this lecture I will start to talk about variables. So what is the variable? Well, variable is basically just a space in memory, okay? So you probably know that computers have something called memory, right? And you can store something in there, okay? And when you store something in there, you can refer to the place in memory, you can refer to it by the name, right? And you can choose the name, okay? So, for example, this line, what this line does? Well, first of all, the message, the MSG, is the name of a variable, okay? And we are basically storing this hello world somewhere in the computer memory, okay? So, I know this may take some time to understand. Computer takes care of the place where we want to store the hello world, okay? Computer does everything for us, okay? And well, basically operating system does everything for us, okay? But all we need to care about is how do we call the space and what are we storing in there, okay? So another thing you may want to do is, for example, define a variable called number. You can have how many of these you want, okay? And in here you can type, for example, a 50, okay? So that means I defined a number. It doesn't necessarily have to be in these quotes, okay? But yeah, you can define a number. Number is not within a quotes. You can define a character, which is like this. Sorry, equals, right? You always say variable equals something, okay? And in here, we will type some character. Let's say A, okay? Cool. So right now, what we can do is, for example, print the number. So in here, we print the message, but we can also print the number. So print, and in here type number. And we can also print the character. So print, and in here character. So cool thing is that when you define and store something in memory, you can refer to the value that is stored in memory via the name, okay? So all you need to do is use the same name in here and in here. But what I will do is basically refer to this A that lives somewhere in memory, and I will pass it into this print function, and this function will somehow take care of the printing. And when I run the application by right-clicking and then write Python file in terminal, as you can see, it says hello world 50 and then A. Okay, so hello world is the message, then it says the number, which is 50, and then it says the character, which is A. So another thing you can do is do this. I will change my mind and I say that the number will be 20. So what happens now? Will this number be changed? Because right now I changed it to 20, right? So what will be actually printed? And if you think there will be 50, you are right. And if you think there will be 20, you are wrong. And what will be printed in here? In here will be printed 20, okay? So when I run this, you should see run Python file in terminal. In here, that's this line, okay? And it says 50. Then the character is printed. Then we change the value that is stored in memory, right? So we change this 50 in memory and we set it to 20, okay? And then we print it. We still, this number is just like a reference. You can think of it as a arrow to somewhere in memory. So in here, we take the reference to somewhere in memory, we point somewhere in memory, and we say, hey, I want 20 in here, okay? And then I print it. So that's about it for this lecture. I hope you understand everything. If you don't, just ask me and I'll see you next time. Okay, so in the previous lecture, we kind of defined some variables and stuff like that. But the variables are pretty much useless at this point, right? All we can do is set a space in memory to some value, right? That's useless. So what we need is some sort of operations, right? We would like to do some stuff with the variables. So for example, in here, I will define a number2 variable. And so I have the number variable and the number2 variable, okay? And I'll just get rid of all of these just to make it clear. And then what we can do? Well, we can define a new variable called number3, for example, and we can set it to the result of some operation, okay? So for example, 10 plus 20, like this. But what we can also do is set it to a operation, and in the operation we will take one variable as a parameter, okay? So for example, instead of the 20 we will use number2, okay? So right now, what will be in the number3 variable? Well, we have 10 plus 20, so that's 30, right? Okay, and what if I change this 10 to 50? Well, to the number variable, okay? Can I do that? Yes, I can. I can use how many variables I want in the statement, okay? So in here, I will simply type number plus number2. Okay, so right now, there should be, in the number3, there should be 70, okay? So if I print it out, if I want to print the number3, I simply type in here number3. And right now, I will run the Python. And as you can see, it says 70, so that's quite cool, right? We can now add, and what we can also do is, for example, multiply, right? So if I run this, it should say 1000, yeah, that's right. And yeah, you can do like minus, divide, and modulo and stuff like that. So you can use all the cool operations that you learned in high school, or maybe probably even earlier, right? Yeah, but never mind. So what you can also do is do some operations with a strings. So for example, a string is just some sequence of characters, right? So basically this one is a string, okay? So when each time you have these quotes inside here, we are referring to this as a string value, okay? Cool. But yeah, so let's define some string variable. String var, let's call this one like this, and let's set it to AAA, okay? And let's define another string var2, for example, and let's say it to BBV, all right? And what we can do with these? Well, we can, for example, define a string variable free, and we can also add these up. Okay, so I will just type string var plus string var2. So what happens? Well, what will happen? You want to add two strings. So for example, what will happen when I ask you to add hello and world together? You will basically say hello world, right? And the same thing will do computer. So in here, if I print the string var2 free, sorry, I will run it, right? So run Python file, and as you can see, it says AAA BBB, right? So it basically put those two strings together, right? And what you can also do is, for example, add another string. So in here, you can add, for example, I don't know, 3 dots. That's up to you. You can use whatever you want. And when you run this, it should say AAA 3 dots and then BBB, because computer doesn't care pretty much whether he adds a variable or just a normal string. To computer, this thing is basically the AAA string, okay? So he doesn't care. You can do all of these. But a problem becomes when you want to add a number. So for example, if I type in here, I will get rid of this stuff and I will set it to number. So what happens when I want to add a string and a number? So let's find out. If I run the Python file, as you can see, there's a type error, okay? So what the type error means? Well, usually when we are programming, you want to keep your code at least reasonably tidy, okay? And somehow you probably don't want to like add a number to a string, okay? Because it's like, it doesn't make sense, right? It's like if I ask you to multiply 10 by a, what's the result of that? You don't know, right? And same is for computer. He don't know what AAA plus 50 means, right? It just doesn't make sense. So he basically telling us that he's telling us, hey, you have type error on this line. And he also tells us the line where the error occurs, right? So string var free equals string var plus number. And he also says can only concatenate strings, not integer to string. So number in the computer is basically a integer. A string is this one, okay? So he tells you basically the same stuff I already told you. So you cannot do that, okay? And if you put multiply in here, let's see what happens. If I run this, it works. Why is that? Well, if you want to multiply a string, it kind of makes sense, right? So for example, if I tell you say hello 5 times, right? You say hello, 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 and I think that was 5 times. I'm not sure, but never mind. So you basically say hello 5 times, and the same goes for a computer. It kind of makes sense to, if you want to say AAA 50 times, it will basically add to the string var variable AAA 50 times, okay? So I can change this one to, for example, 2, so that you can actually see it. I don't want to calculate all the a's in here, but when I change it to 2, in here will be AAA, because we are referring to this value, and then we are multiplying by 2. So there's 6 A's in the result, okay, in this variable, and we are then printing it. So yeah, I hope this makes sense, and I'll see you next time. Okay, so let's take a look at numbers. So in Python we have 3 types of numbers. First one is the integer. You probably know it, right? So number equals to some integer value, like 5, or it can be like this, or it can be even minus, right? So we can have negative values, you can have positive values. That's cool. But what you can't have is a decimal point in here. So you cannot have something like 5.0. That's too bad, right? But, well, you actually can have it in here, okay? This number works. But when you add the decimal point in here, this number becomes float, okay? So you have a floating point number. That kind of makes sense, right? And you can also have a complex number. So what is complex number? Well, that's for further purposes, but if you know what complex number is, you can add the imaginary part by j. So for example, plus 5j, okay? So this is still a number, it's only a complex number, but don't worry about it if you don't know. So then what you can also do is print the type. So for example, well, not only print the type, you can get to the type of variable by writing type, and then inside parentheses you write number. So what this one does? Well, we basically ask what type is the number variable. Computer says, okay, I get it, it's a float. And it is returned, right? It returns a float instead of this stuff, okay? And then we print it. So if I run this program, it should say, yeah, class float. So why is there the class? Don't worry about it right now, okay? Just the important thing is that it is a float, and when I remove this stuff and say only 5 and run this, it should say int, okay? And if I add like 2j, it should say complex. So if I run this, it says complex, okay? So that's how you can figure out a type of a variable. And another thing I may want to show you is, for example, that you can add the variables. So for example, if I type in here number and then number 2, and that will be just a floating point number. If I add in here number 3 and set it to the number 2 times number, what will be the type of number 3? So yeah, let me change this one so that it is more interesting. What will be the type of number 3? So we have 2 times 2.5, so that's a 5, right? But you would think that this might be a integer, right? But it's not. It's a float. So if I run this, you will believe me. So in here I will just type number 3. So we are asking for the type of number 3, and as you can see, it says float. Why is that? Well, even though the number is 5, the number is 5.0, because the computer knows that he's taking a float and he's taking a integer. And what is more precise, right? Float is more precise because it have the decimal point, right? So what will be the result? Well, we would like the result to be the most precise number, right? So it will also have the decimal point. I hope that makes sense, right? So if I print this, it should say 5.0. Okay, so if I run this, it says 5.0, not only 5, but 5.0. Even though the number behind the decimal point is nothing, the computer still likes to add the precision, okay? Cool, so that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Okay, so in the previous lecture, we kinda defined some variables and stuff like that. But the variables are pretty much useless at this point, right? All we can do is set a space in memory to some value, right? That's useless. So what we need is some sort of operations, right? We would like to do some stuff with the variables. So for example, in here, I will define a number 2 variable, and so I have the number variable and the number2 variable, okay, and I'll just get rid of all of these just to make it clear. And then what we can do, well, we can define a new variable called number3, for example, and we can set it to the result of some operation, okay, so for example 10 plus 20, like this. But what we can also do is set it to a operation, and in the operation we will take one variable as a parameter, okay, so for example instead of the 20 we will use number2, okay. So right now what will be in the number3 variable? Well, we have 10 plus 20, so that's 30, right? Okay, and what if I change this 10 to 50? Well, to the number variable, okay? Can I do that? Yes, I can. I can use how many variables I want in the statement, okay? So in here, I will simply type number plus number2. Okay, so right now, there should be, in the number3, there should be 70, okay? So if I print it out, if I want to print the number3, I simply type in here number3, and right now I will run the Python. And as you can see, it says 70, so that's quite cool, right? We can now add, and what we can also do is, for example, multiply, right? So if I run this, it should say 1000, yeah, that's right. And yeah, you can do like minus, divide, and modulo, and stuff like that. So you can use all the cool operations that you learned in high school, or maybe probably even earlier, right? Yeah, but never mind. So what you can also do is do some operations with a strings. So for example, a string is just some sequence of characters, right? So basically this one is a string, okay? So when each time you have these quotes inside here, we are referring to this as a string value, okay? Cool. But yeah, so let's define some string variable. String var, let's call this one like this, and let's set it to AAA, okay? And let's define another string var2, for example, and let's say it to BBB, alright? And what we can do with these? Well, we can, for example, define a string variable free, and we can also add these up, okay? So I will just type string var plus string var2. So what happens? Well, what will happen? What you want to add two strings. So for example, what will happen when I ask you to add hello and world together? You will basically say hello world, right? And the same thing will do computer. So in here, if I print the string var2 free, I will run it, right? So run Python file, and as you can see, it says AAA BBB, right? So it basically put those two strings together, right? And what you can also do is, for example, add another string. So in here, you can add, for example, I don't know, 3 dots. That's up to you. You can use whatever you want. And when you run this, it should say AAA 3 dots and then BBB, because computer doesn't care pretty much whether he adds a variable or just a normal string. To computer, this thing is basically the AAA string, okay? So he doesn't care. You can do all of these. But a problem becomes when you want to add a number. So for example, if I type in here, I will get rid of this stuff and I will set it to number. So what happens when I want to add a string and a number? So let's find out. If I run the Python file, as you can see, there's a type error, okay? So what the type error means? Well, usually when we are programming, you want to keep your code at least reasonably tidy, okay? And somehow you probably don't want to like add a number to a string, okay? Because it's like, it doesn't make sense, right? It's like if I ask you to multiply 10 by a, what's the result of that? You don't know, right? And same is for computer. He don't know what AAA plus 50 means, right? It just doesn't make sense. So he basically telling us that he's telling us, hey, you have type error on this line, and he also tells us the line where the error occurs, right? So string var 3 equals string var plus number. And he also says can only concatenate strings, not integer to string. So number in the computer is basically a integer. A string is this one, okay? So he tells you basically the same stuff I already told you. So you cannot do that, okay? And if you put multiply in here, let's see what happens. If I run this, it works. Why is that? Well, if you want to multiply a string, it kind of makes sense, right? So for example, if I tell you say hello 5 times, right? You say hello, 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 and I think that was 5 times. I'm not sure, but never mind. So you basically say hello 5 times, and the same goes for a computer. It kind of makes sense to, if you want to say AAA 50 times, it will basically add to the string var variable AAA 50 times, okay? So I can change this one to, for example, 2, so that you can actually see it. I don't want to calculate all the a's in here, but when I change it to 2, in here will be AAA, because we are referring to this value, and then we are multiplying by 2. So there's 6 a's in the result, okay, in this variable, and we are then printing it. So yeah, I hope this makes sense, and I'll see you next time. Okay, so let's take a closer look at strings. So what is string? Well, this is a string, okay? But this is also a string. So you can either use the double quotes or single quotes, and yeah, these both things are the same, right? So they are equal, okay? And what you can do with strings? Well, there's a lot that you can do. So for example, I will define a string variable, and I will set it to hello, okay? So some space in memory, hello as a value. Cool. So let's say that I would like to print the first character that is in the string. I can do that because the computer represents string as an array of characters. So basically, even though this is still in memory, it splits it into single characters, and they are next to each other in the memory, okay? So I can ask for any character that is in the memory. Cool, right? So if I want to print, for example, the first character, I can do it simply by writing string var. That will print the whole string, okay? But what I can also do is ask for a specific character, okay? So for example, character at index 0. So if I run this, it should print age, and it does, okay? So why is that? Well, first of all, we are indexing from 0, and so the age is character at index 0, this one is on index 1, and so on, so on. So we are basically accessing the string, but only the small part, only one character from the string, okay? And we can ask for any character. So if I ask for the next one, now it will print E, right? As you can see, there is E, and you can do it with like, right, there's 0, 1, 2, 3, 4, okay? So the last should be on index 4, so that should be O, okay? There it is. But what happens if I go to 5, right? 5 is somewhere that is not, it's behind the string, right? It's more that I can ask for. So if I run this, I get a error. So this error says string index out of range. So what that means? Well, I basically reached too far, and I am trying to grab something that is not in the variable, okay? But if I add some character in here, it would work, and it will print age. And another thing you can do is print a characters of some part, okay? So for example, I want to print from position 1 to position 5, Okay, so when I run this, you will see the result. Okay, so I'm grabbing only a substring of this whole variable. Okay, so I am basically taking I'm leaving out the character at index 0, and I am taking the character on index 1, 2, 3, 4, right? The 5 is not included. That's why this H is not in here. Okay, so you can do like all kinds of stuff with this. You can even trim it more, right? Right now the O is not included. Also, you can start at different positions. So for example, from 2, right? That's up to you. And that's quite cool. That's quite a useful tool, right? You can simply just pick a subpart of string, and it's very easy to do so. Okay. So another thing that you may want to do is figure out a length of a string. So how do you do that? Well, remember, as we do the type definition and stuff like that, simply type in here len as a length, and then we pass in there the string variable like this. So this will print how long the string is. So if I run this, it should say 6, right? 1, 2, 3, 4, 5, 6. Cool, right? So we start indexing from 0. So the last character that we can index is on index 5, okay? That makes sense? I hope it does. And another thing you can, for example, do is get rid of white spaces before and somewhere at the end of your string, okay? And how do you do that? Well, simply type in here string var, then dot, okay? So dot, that's important. And then you can simply type strip, and once again parentheses, but they will be empty, okay? So if I run this right now, it prints the same string, right? This is the same string, the content is the same, right? And the spaces in between the characters, in between the pseudo words are there, right? But the spaces in front and at the end are deleted, okay? So that's quite cool. If I print it without this, you should be able to see the difference, right? There's a spaces in front and behind. You can't see the spaces behind, but trust me, they are there. And yeah, so that's one thing that you can do. Okay, another thing that you can do is simply turn a string into a uppercase or a lowercase, okay? So for example, in here I will type shut up. And I want it to seem like I'm screaming, right? Right now it doesn't seem like I'm screaming. If I print this, it just say shut up, and it's just boring. But if I capitalize it, it would look much better, right? So if I add a dot into the string var dot and then capitalize and then parentheses, I will simply run it, and as you can see, the first number is capitalized, right? So that's kind of cool, right? And another thing you can do is make it even a brutal caps lock, right? So do a upper as a uppercase, right? And when I run this, it's like shouting at me, shut up, right? So yeah, that's too bad. But anyway, right, you can do this stuff. You can turn it into a uppercase, and you can do the same thing with a lowercase. So for example, if I do a shut up like this, right, I can turn it into a lowercase by typing lower, right? That should make sense, kind of, right? That's a good name for a lowercase method. So that basically takes the value of the string and turn all the characters into a lowercase. So shut up. And yeah, you can also do a stuff like replace some character with another one. So for example, in here I will do sh, and then let's say that I want to replace. The cool thing about the suggestions of the extension that we installed is that it tells you, okay, you want to replace, right? I know that method, and it tells you in here you type the old character, then you type in here the new character, and then you type in there the count, but the count doesn't necessarily have to be there, okay? So for example, if I want to replace the H with a A, I can do that. So if I run this, it says SA instead of SH, right? So it basically takes all the ages from the string and converts it into a, right? And then it prints it. Cool. And you can also assign it to another variable and then print the variable. So if this doesn't make sense, maybe try it like this. So string var2 will be equal to this one, okay? And then we'll print the string var2. Okay, that might give you a little bit of sense, right? The result is still the same, okay? And another thing that you can do is split these strings so that you have a different strings, okay? So if I, for example, put a space inside here and I would like to split it, okay? I would like to tear that apart, I can do that. So in here I will like write a split, okay? And I would like to split it when there's a space, okay? So each time the space occurs, so that means in here and in here, I would like to break it down, okay? So in the string var2 we will have a array of a string. So if I run this, you should be able to see it, okay? As you can see. So basically the square brackets stands for array, okay? That's a data structure, basically the same as the string, right? But inside the array we have something called elements, okay? And this one is a string, this one is also a string, and this one is also a string, okay? So yeah, this don't worry too much about if you don't understand the array concept. We will get to it later on in this course, okay? So yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Well, hello guys and welcome to this lecture. In this lecture I will show you how you can take input from a user. So that will be quite cool. So let's get into it. First of all, let me define a message variable, right, like this, and let's say it should say something like, let's say your name, okay? So that's just the thing that we do. We ask for a name of the user, okay? Then we would like to print the message so that user can see it. So print message. So far you already know everything, right? No need to explain. So right now we would like to get the name of the user, right? So we would like to user to type the name on his keyboard and we would like to work with that. We would like to store it as a variable, okay? So how do we do that? Well, in here we simply type the name of the variable. So user name, for example, like this. And then we will assign it to a value of what user wrote. And once again, computer does all of the heavy lifting for us. All we need to do is simply type in here input like this, and it will basically ask the user to enter something, okay? And then it will take the something user wrote and set it to as a value of this username variable. And then what we can do is, for example, print a string that says hello, and then we will add the username, okay? So it's a simple application. So if I run this, it starts and it says your name, and then it waits for me to input something. So I will simply type my name, Luke, and then hit enter, and this will basically fire the input and put the Luke as a value of this username, okay? And then we can print hello Luke, okay? So that's quite cool, right? You can make a simple applications via this. So yeah, and another thing that you may want to find out is that I can ask for a type of the username so that you can see what type it is, okay? So if I run this, yeah, I will just type Luke. Oh, sorry, I need to click inside here, okay? And in here type Luke, and yeah, it prints hello Luke, same as before, but it also tells me that it is a string, okay? So now you may wonder what happens if I type in here something like 2, right? 2 is not a valid name, so what happens? Well, it's not a number, it's a string, okay? So even though I type 2, the user input is always a string, okay? So even though you think that this is a number, it still works, right? You can add a string, and as you can see, it is of class string, okay? So the type of the username is string, even though it is 2. So yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so let's get to the fun part. We will create our first kinda useful application, and it will be a calculator. So let's get into it. First of all, what calculator does? Well, we would not create the conventional calculator with buttons and stuff. We'll basically ask user for 2 numbers, and then we will do all the plus, divide, times operations for the user, and we will print it out on a screen, okay? So let's do that. First of all, we would like to print to the user, so print, and then we would like to print something like enter first number, okay? And then we would like to take the input, so first number, so we will create a variable, and in there we will store whatever user wrote, okay? And then we will ask for a second number, so I'll just copy paste it to save some time. So enter second number, and in here I will also change the name of the variable to second. And cool, so we have the 2 numbers that user wrote. Right now what we want to do is do all kinds of operations and then print it out, okay? So can we do this, print, and then first number plus second number? Would this work? Well, you may want to pause the video and think about it, but I can tell you right now, it will not. Because if I add, for example, 2, oh sorry, I need to click in here. If I add 2 and 5, it should be 7, right? But it's 25. Why is that? Well, these 2 are strings, right? So we are not working with integers, we are working with strings. So we can't simply do this. So what we can do? Well, we can change it to an integer. So we basically take what the user wrote, change it to integer, and then set it as a value to the first number. And we can do the same inside here. And you can even change it to float, that's up to you, right? I will just do it with integers. And then when I run this, it should work. So if I type in here 2 and 5, it says 7. So we got a calculator, very basic calculator. But yeah, we get one. So what we want to do? Well, we would like to print all the operations, right? So plus, times, divide, minus, right? So times, divide, minus, we can even do modulo, right? Okay, modulo, that's up here. And we can, right now, we have a working calculator. If I run this and type in here, for example, 10 and 5, here you have the results, right? It says, sorry, I'll make it a bit bigger, 5. So it says 15, 52.5 and 5 and 0, which is correct, right? But what I would like to do is kind of make sure that what I'm right now, as I'm looking at these numbers, I'm not sure what's the expression, right, that results into it. So I would like to print, for example, 10 plus 5 equals 15, okay? So in order to do that, I will simply turn into a string the first number. Then I will add the plus sign, okay, so like this, and I will put a space in there. Then I will put into a string the second number, okay. Then I will add the equal sign to it, and then I will finally put into a string the, well, I will once again concatenate it, and I will put into a string the result of this operation, okay? So I need to also close this one up. And cool, so if I run this right now, it says enter first number, 5, second will be, for example, 8, and as you can look at this first line, it says 5 plus 8 equals 13. Okay, so if there would not the type conversion, this wouldn't work because we would try to add a number and a string, right? So we need to convert the numbers into a string, and yeah, and then we simply concatenate it with a characters, with a strings. Okay, so as your challenge, you need to change all of these so that in here it says like first number times second number is equal to, yeah, so it looks basically the same as in here. Okay, so yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright guys, so in this lecture let's take a look at some more advanced operators. So let's get into it. First of all, I will define a number, and let's say it will be a 10. And then I will define a number 2, and I will put it as a result of, for example, exponentiation. Okay, so for example, 10 to the exponent of 2. Okay, so if I then bring the number 2, okay, you should be able to see it. You should be able to see quite big number. If I run this, it's 100, right? Because 10 to the power of 2 is 100, and if I run this again, it will be 1000, right? And so on, right? 10,000. So yeah, that's the exponentiation. Okay, then what you can do is do a floor division. So what that means, well, basically the result after this operation will get rounded. Okay, so if I run this, as you can see, it says 2. Why is that? Well, 10 divided by 4 is 2.5, right? But since we are doing the floor division, we are getting rid of everything that is behind the decimal point, right? So we have only 2. Okay, cool. So another thing that we can do is do a something like plus equal. Okay, so for example, right now we set number 2 to 2. Okay, and then we can do something like this. So number 2 plus equal 1. So what this will do, well, it will just add this 1 to the value that is currently stored in number 2, and that it will store it as a result of in number 2. So if I run this, it says 3, okay, because number 2 is now 3. We took the 2 that was in the number 2 variable before, and we add to it 1 and store it as a new value to the number 2 variable. So basically this line is the same as typing number 2 equals number 2 plus 1. So yeah, that's another cool thing that you can do. You can refer to a variable in the expression and then assign the result of the expression as a value to the same variable. Okay, this is fine, this will work. Okay, so if I comment this line out, or if I just delete it, okay, you should see that the result, the number 2 is still 3. So if I run this, it says 3. Okay, so these two lines are the same. Okay, cool. And right now I touched on another thing that I would want to mention, and that is comments. So in programming, you want to write comments because when you write some complex application, you need to type something to a line to know when you are looking at the code like 1 month later, you should know what this line does. Okay, so when you want to type comment, you can say this line adds 1, right? And stuff like that. And what this means, well, the computer won't evaluate this thing as a expression, right? He will just reach this hashtag, and then he will say, okay, what's behind is just for the user, not for me, so I will not take a look at what it says. Okay, so yeah, cool. Another thing that you can do is, instead of this plus equal, you can do times equal, minus equal. You can use all of the operations that you know. Okay, so yeah, for example, if I do times equal 1, this should just say 3, and if I comment this line out, it will say 2, okay, because 2 times 1 is 2, okay, and if I change it to 2, it will say 4, okay, cool. And yeah, so that's one part of the advanced operation that you can use. If you have any questions, feel free to ask, and I'll see you next time. Alright, so the comparison operator are used to compare two values. Okay, so for example, in here I will type number and I'll set it to 10, and in here I will write number 2 and I'll set it to 20. And if I want to print out whether, well, first, yeah, I will print it out. So let's print some variable called result, and in here we will define the variable result, and this one will be equal to, for example, something like number is equal to number 2. Okay, so if we want to find out whether two numbers are equal, well, whether two variables are equal, we write two equal signs, because the one equal sign is the assignment operation, right? So we need to type in here two equal sign, and when I run this, it says false. So why is it? Well, 10 is not equal to 20, right? So that's why this one says false. And then if I type in here, for example, not equal to 20, which means this exclamation mark equal sign, okay, so this one means not equal. So if 10 is not equal to 20, we will have a true, and this should say true. If I run this, it says true, okay? And if I, for example, change this one to 20, they are equal now, right? So 20 is not equal to 20 is nonsense, right? They are the same. So if I run this, it should say false. Yeah, and it does. Okay, so another cool thing that you can do is, for example, ask whether a number is smaller or equal to something, right? So all the operations that you know from middle school. So if you type in here this one, it says number is smaller or equal to number 2. So if I run this, it says true because they are equal, right? And if I, for example, change it to 19, it says false, right? Because it says false because, yeah, 19 is smaller than 20, right? So yeah, but if I change it to this one and says number is greater than number 2, it should work. So if I run this, it says true, right? So these are all the logical operations that you may want to use, okay, sometimes, and they are heavily used in condition, and we will get to it later on, okay? So right now, all you need to remember is that all of these operations are returning a value that is either false or true, okay? And yeah, that's about it. So you can compare two values using two equal signs, you can compare it using not equal, so a exclamation mark and equal sign, okay? And then you can use all the arithmetic kind of operation, right? Greater than, smaller than, stuff like that. And another thing that we have is a logical operation. So what is a logical operation? Well, logical operators are used to combine conditional statements. So for example, this thing is a conditional statement, okay? And we can combine them together. So if I, for example, put a parenthesis inside here and then type in here and another conditional statement, I can do that. So for example, in here I will type number is equal to number 2, right? So this one will be obviously false. Why is that? Well, I am asking the and, basically this is a logical operation. If at least one of the expression is false, the result is false. But if all of the expressions are true, the result is true, okay? So in order for the result to be equal to true, we need to have all of these expressions equal to true, okay? I hope that makes sense. So if I run this, it says false. Why is that? Well, number is not equal to number 2, right? So this one is false. And even though this one is true, because number is greater than number 2, it's still the final result due to the AND operation is false, okay? And right now I can also use the OR operation. So what the OR operation does? Well, the result is true if at least one of the expressions is true. Okay, so it is true if at least one of the expression is true. So this one is true. So even though this one is false, the result is true. So if I run this, it says true. Cool, right? And yeah, so if I, for example, change this to the opposite, so if I say number is smaller than number 2, which is false, and then do OR operation and then another false, the result will be false. So if I run this, it says false, okay? Because there's none of the expression that will result into true, okay? And another thing that you can do is the negation. So what negation does? Well, it basically flips the value. So if you have a false, it will flip it into a true. And if you have a true, it will flip it into a false, right? So how do you do that? Well, simply type in here not. So you can also read this stuff, right? So if you read it from left to right, it says the number is not smaller than the number 2. And the number is not smaller than the number 2. That's true, right? So if I run this, it says true. Even computer knows that. So yeah, these logical operations are kind of maybe a bit more advanced. So don't worry if you don't understand everything now. We will get to it even later in this course. Alright, so let's talk about conditions. Conditions are a great tool and you will definitely use it in your applications. So it's important to know how they work. So first of all, we got there the if condition. And what that allows us to do? Well, it allows us to control which part of code will be executed. Alright, so I'm quite sure that this doesn't make sense right now, but think of it this way. If you tell somebody if something is happening, then do something, okay? That's usual way you tell something to people, okay? And you tell the same thing to computer. So if some condition is true, do some code, okay? So let's try it out. So if you want to define a if condition, simply type in here if, then you type the condition. So if, for example, bigger number is greater than the smaller number, smaller number, like this, I can type, and then do something. And the then part you define by a column, and then you, on the next line under, you write what you want to happen, okay? So for example, you can print something on a screen like bigger number is bigger. Who would have guessed that, right? So yeah, so what that does? Well, computer evaluates this thing as a just normal command. He goes and checks out, alright, there's if, so I need to check whether this condition is true. And is 10 greater than -5? Well, yes it is, right? So then the computer looks at the lines that are in here and executes them, okay? But if this condition is false, this line will not be executed. So let me also put something at the end of the program. So for example, I will print in here the program ends, so that you are sure that the program ended, okay? And let me run this thing. So as you can see, there it says bigger number is bigger and then program ends, okay? So basically it happens as I said, right? This condition were true, so this line were executed, alright? And if I, for example, change this to say bigger number is smaller than the smaller number, which is a complete nonsense, right? This line will not be executed and we will see only the program ends, okay? So if I run this, we should be, we see only the program ends, right? This line is not in here, okay? Cool. So this is basically how the if condition works. You can put in here multiple statements. So for example, print, I don't know, right? You can do whatever you want, right? You can assign a value to this, right? And this one will be changed, right? And then I will run it, and as you can see, there are, I don't know, bigger number is bigger, and then the program ends, okay? So yeah, and how do you define which line will be executed if the condition is true? So as you can see, these two lines are executed if the condition is true. and this line is executed no matter what, right? If the condition is false, we still saw the program ends. So from that, you might figure out that this step is extremely important. This step defines which line we want to execute if something is true, okay? So these steps are extremely important. When you want to end the if condition, you simply start typing from the beginning of the line, okay? So the space matters. And yeah, so what happens if I, for example, forget about this and I put this print in here? Let's see if I run this. As you can see, there's an error. Right now, the computer goes to the if condition and there is something that is true. And he says like, all right, I want to execute some code, and there isn't any, okay? So we get an error, okay? I hope that makes sense. And what happens if I put the condition to be false, right? So if I say bigger number is smaller than the smaller number, which is nonsense, this is false, right? So this condition is not met. So will it matter to computer? If I run this program, as you can see, it doesn't matter. Even if the condition is false, we still need to have some statements in here so that the computer knows, right, that there's some code he can execute if the condition is true. Alright, so yeah, that's pretty much it. That's how you can define a if condition. You can have multiple of them, right? So you can define another if condition in here and say, for example, I know bigger number is equal to the smaller number, right? Then right column, and in here some stuff. So you can even like assign a value to the bigger number, for example. You can do whatever you want in here, okay? And yeah, that's pretty much it for this video. If you have any questions, feel free to ask, and I'll see you next time. Alright, so in this lecture we will take a look at the else if condition. So what is the else if condition? Well, let me write an example and then let me talk you through it. Okay, so we write simply elif like this. So not the entire else if, but only elif. Alright, and then we write some other conditions. So for example, bigger number is greater than smaller number. Alright, and then colon, and then we can, for example, print something, right? So maybe this line, I will just take it from here and paste it inside here. Alright, so what that means? Well, the else if must be directly under a if branch. Alright, so when one if ends on the line under, we need to have else if. Well, we don't necessarily have to have it in there, right? But if I, for example, type else if somewhere else, so for example in here, we would get an error, right? So if I run this, we get an error that the else if is invalid, right? Because we need to have the else if branch directly under the if. And this should make sense because right now I'm about to explain what the else if does. And the else if basically takes a look at the condition only if all the if branches above were not met. Okay, so if this is false, right? So if this condition is false, this code will not be executed, and the computer goes and checks this else if, and he says, alright, so this condition above was not met, so I will check this one and see if I get lucky, right? So he checks this condition and see that this one is true. So that's cool, right? And he can execute this code, okay? So this else if branch is executed only if the if branch above was not met, okay? This is important. So if I run this right now, you should be able to see the bigger number is bigger, all right? And why is that? Well, this condition is nonsense, right? This is false. So this line is not executed. Then the computer goes to the else if branch and see that this line, this condition is true. So he executes this line, all right? And what happens if I, for example, change this condition so that it is true? What happens? Well, the computer goes in the if branch and see that this one is true. So he says, okay, cool, executes this code, right? Same as before. But then he goes out and kind of skips this else if branch. Okay, so all the code that was inside the else if branch, he won't even evaluate the condition, right? So he says, alright, I already got one condition that is true and that's enough for me. And he goes directly on the line 8 in here, okay? So yeah, so let me for example run this code. As you can see, there should be printed I don't know, and then the program ends, right? So yeah, it's exactly as I said, right? And it doesn't matter whether the condition is true, even though this one is the same condition, so it is also true. The computer doesn't evaluate this thing, okay? So yeah, and another thing that you can do is, for example, I will say this condition is false, and then I will say this condition is also false because bigger number is not smaller than smaller number. So what happens now? Well, the computer simply goes into the if and says, alright, this is false, that's too bad. And he says, but there is the else if branch, so cool. And then he goes inside this condition and figure out that this is also false. So yeah, he doesn't execute even this code, and then he goes directly under, okay? So as you can see, none of this prints happens, right? We only see the program ends inside here. So yeah, what you can also do is define multiple else if branches. So for example, else if, and as I said before, the else if must be directly under the if condition or directly under another else if condition, alright? So in here I can for example say bigger number is greater than smaller number, and then I can print, I know something that isn't in here, so this is happening. Alright, and if I run this program, the this is happening should be printed. As you can see, it is, because why? So computer goes to this if, it's false, so he skips this, goes to this else if, it is also false, so he skips it, and goes to this else if, right, to the last else if, and he figures out that this one is true, right? This is true, so he prints this and he's done, right? So this is basically the else if branch, right? I only want to make sure that you understand that if I put something in here, we get an error. So for example, if I set the smaller number to 10 in here, right? As you can see, it is not part of the else if branch because there is no space in front of it, right? So if I run this code, as you can see, we get the error because the bigger number, right? Because this line, basically the line 9, is not directly under another else if branch, okay? Right? It has to be directly under, alright? So yeah, that's pretty much it for this video. If you have any questions, feel free to ask, and I'll see you next time. Alright, so let's talk about the else branch. What is the else branch? Well, else branch is basically something that we can use to define something that will happen if none of the conditions above was met, okay? So if I, for example, type in here else, and then I write only the column, alright? And then in here I print, like, for example, I don't know, else branch. Well, or just else. And yeah, so this will be printed, or this code inside the else branch will be executed only if all of the conditions above were not met, okay? I hope that makes sense. So for example, if I type in here another nonsense like this one, right? This condition will not be met, this one also will not be met, and this one also, right? So as you can see, we see this else printed, okay? So yeah, as I said before, this computer goes to the if, figures out this is false, okay, he's sad, bad, right? He cannot execute this line, so he goes to this else if and tries, and still false, so he also cannot execute this line, and goes to this last else if, and he really hopes this will be true, but it is not, so he cannot execute this line. But thankfully we have the else branch, and inside here we have the print else, so computer finally find the code he can execute, alright? I hope that makes sense, right? So the else if else branch needs to be placed as a last statement in the if statement, right? So if you have all of these statements above, the else must be the last, because we are defining something that is happening when none of the conditions were not met. So it kind of doesn't make sense to put some other else if in here, right? So like this, right? That shouldn't make sense. Sorry, like this. And yeah, so just so you can see, I will just put it in there, and as you can see, we will get a error. So if I run this program, it should say error, yeah, else if, right? It's not placed directly under else if or if, alright? So we get an error, alright. So the else must be directly under else if or if, and it must be the last condition. Alright, so for example, you don't necessarily have to have the else if in there. So if I go and write, for example, if bigger number is smaller or equal to smaller number, alright, we can, for example, print something. Alright, so something, and yeah, I accidentally click on caps lock, but never mind. And in here we define the else branch. Alright, so this works. We can define a else branch when we only have a if above. Alright, so in here we'll print something like else2. else2. Alright, and if I run this program, you should be able to see else2. Yeah, you do, because the else2 is this branch, right? This condition above was not met, so this will not be printed, and then computer goes to this else branch and he finally prints something. Alright, I hope this makes sense. The else condition is, in my opinion, the easiest one to understand, right? Basically, if all of the conditions above were not met, the else condition will be executed, and yeah, it must be exactly at the end of every if statement, right? So yeah, you can have if statement without the else condition, don't get me wrong, right? This is still valid, alright? This still works, alright? But the else statement, if there is a else statement, it must be placed directly at the end, alright? And that's pretty much it for this video. If you have any questions, feel free to ask, and I'll see you next time. Alright, so let's create a functioning application that will test whether the number that user wrote is a positive, negative, or a 0. Alright, so let's do that. So simply in here we will print something like, I don't know, enter number, like this. Then we will ask for the number via the input, right? You should know that. So in here I will define a new variable called number, and I will simply get the input from the user. Alright, so right now we also need to change the data type of the input that the user wrote, because this is a string, right? So we will change it to a integer, like this. And then we have a real number in this number variable. So what do we want to do? Well, first of all, we would like to check whether the number is smaller than 0, right? If it is smaller than 0, we would like to print that the number is negative, right? So let's do that. Simply in here type if, and then number is smaller than 0, and we would like to then print the number is negative. Alright, and then what we want to do? Well, in other case, if the number is equal to 0, we would like to print the number is 0, right? So there are a couple of ways we can do that. We can either define another if condition, alright, but we can also do a else if, right? So since we are checking for the same number, I would probably use the else if, but if you go with if, there's nothing wrong with that, alright? But I'll use the else if branch, and in here I will check whether the number is equal to 0. And if it is, I will simply print number is 0, right? Because it is 0. Alright, and the last case is that the number is greater than 0, alright? But is there any other case? If we go to this point, right, we know that the number is not smaller than 0, because if it was smaller than 0, we would break out, right? And we also know that the number is not 0, because if it were 0, this condition would be met, we would print number is 0, and then we would break out, alright? So what we can do is define the else branch, right? So else, and then we can print number is positive, right? Like this, right? So let me go through it once again. This else branch is basically the same as typing else if number is greater than 0, right? So this is the same thing. Why is that? Well, we have three cases that can happen, right? The number is either negative, right? The number is either positive, or the number is equal to 0. Alright, and if you remember correctly how the else and if else and all the conditions work, It works that we first of all check for a condition. If it is true, we do the code and then break out, alright? So the other conditions are not met, alright? And then if the else if condition is also true, we check for the condition, right? If it is true, we print this line and then once again break out and continue with the lines directly under, alright? And and if all the conditions above were not met, we go to the else branch, alright? So this thing is basically same, in this case, it is basically same as typing in here only the else, right? So if I run this program, it asks me to enter a number. I will enter, for example, a 50, and it says number is positive. Why is that? Well, number is not smaller than 0. Number is not equal to 0. And we go to this else branch, alright? So if I, for example, run this again and put in here 0, put in here 0, we get number 0, right? So this is working. Why is that? Well, we check this condition, it is false, so we are not printing this line. Then we check this condition, it is true, so we print this line and we skip the else branch. Alright, I hope that makes sense. And if I run this program once again and type in here something like -50, oh my god, you have to click in here and type -50, we get the number is negative. Why is that? Well, number -50 is smaller than 0, right? So we print this line and then we skip this whole code. Okay, so that's one program that you can use for some reason if you are not sure whether a number is positive or negative. But yeah, it doesn't matter, it's mostly for the teaching purposes, right? So yeah, if you have any questions, feel free to ask and I'll see you next time. Alright, so let's talk about the else branch. What is the else branch? Well, else branch is basically something that we can use to define something that will happen if none of the conditions above was met. Okay, so if I, for example, type in here else, and then I write only the column, alright, and then in here I print, like, for example, I don't know, else branch, well, or just else, and yeah, so this will be printed, or this code inside the else branch will be executed only if all of the conditions above were not met. Okay, I hope that makes sense. So for example, if I type in here another nonsense like this one, right, this condition will not be met, this one also will not be met, and this one also, right? So as you can see, we see this else printed. Okay, so yeah, as I said before, this computer goes to the if, figures out this is false. Okay, he's sad, but right, he cannot execute this line, so he goes to this else if and tries, and still false. So he also cannot execute this line and goes to this last else if, and he really hopes this will be true, but it is not. So he cannot execute this line, but thankfully we have the else branch, and inside here we have the print else. So computer finally find the code he can execute. Alright, I hope that makes sense, right? So the else if else branch needs to be placed as a last statement in the if statement, right? So if you have all of these statements above, the else must be the last, because we are defining something that is happening when none of the conditions were not met. So it kind of doesn't make sense to put some other else if in here, right? So like this, right? That shouldn't make sense. Sorry, like this. And yeah, so just so you can see, I will just put it in there, and as you can see, we will get a error. So if I run this program, it should say error, yeah, else if, right? It's not placed directly under else if or if, alright? So we get an error, alright. So the else must be directly under else if or if, and it must be the last condition, alright? So for example, you don't necessarily have to have the else if in there. So if I go and write, for example, if bigger number is smaller or equal to smaller number, alright, we can, for example, print something, alright, so something, and yeah, I accidentally click on caps lock, but never mind. And in here we define the else branch, alright, so this works. We can define a else branch when we only have a if above, alright. So in here we'll print something like else2, alright. And if I run this program, you should be able to see else 2. Yeah, you do, because the else 2 is this branch, right? This condition above was not met, so this will not be printed, and then computer goes to this else branch and he finally prints something. Alright, I hope this makes sense. The else condition is, in my opinion, the easiest one to understand, right? Basically, if all of the conditions above were not met, the else condition will be executed, and yeah, it must be exactly at the end of every if statement, right? So yeah, you can have if statement without the else condition, don't get me wrong, right? This is still valid, alright? This still works, alright? But the else statement, if there is a else statement, it must be placed directly at the end, alright? And that's pretty much it for this video. If you have any questions, feel free to ask, and I'll see you next time. Alright, so what is a tuple? Well, tuple is basically the same thing as list, only in tuple you cannot change the elements, right? So you cannot change the value of elements. So let me show you. For example, in here I will create a tuple variable, and I will define it like this, right? So you use parentheses, and inside you write the elements. So for example, Apple, and then Google, and then stuff. Alright, like this, right? So we created a new tuple. Then what we can do is, for example, try to set the value on index 1. So same thing as before, right? And we can change it to, for example, DDD, whatever. And then we can print some element on index 1. Alright, so print tuple variable on index 1, right? So that's quite easy, right? You already know this stuff. But the difference is that we get a error. Okay, so why is that? Well, the tuple object, right, which is this tuple variable, right, it does not support the item assignment, right? So we cannot assign anything to it. So that is why we can't change any values that are stored in the tuple, right? So if I run this like this, it will work, right? So we print Microsoft, that is this code in here, and then we print Google, all right? So yeah, you can also comment this one out just to see only the stuff that we are working on. And as you can see, it says only Google, alright? And yeah, so that's the main difference between tuples and lists. In tuples, you have the same value. You can have same value multiple times in here. So for example, in here you type Google, right? And this will also work. Yeah, there is no problem in having same values multiple times. So for example, if I ask for the value on index 3, we will get the same result, right? Google. All right. So yeah, that's pretty much it for this lecture. The tuples works exactly same as sets, only you cannot change the value. All right. Alright, so what is set? Well, set is another data structure, so basically a collection of variables, same as before. But this time you cannot index the variables, so you cannot use this thing. Alright, so let me just define a new set by writing, for example, my set, and then when you want to define a new set, you simply type in here the curly brackets, right? And I'll simply copy the elements and paste them in here. Alright. And then what you can, for example, try to do is try to access some element on some index, right? So you can type my set and then index, like for example 0. And if you try to run this thing, it will get a error, right? Set object does not support indexing, so you cannot do that. And if you try to print the set, you can do that. So if I run this, as you can see, there's Apple, Google stuff. So why isn't there the other Google? Well, that is because the set does not support duplicates, okay? So you cannot have two values multiple times, or like you can have, you don't have a error, but if you try to add a Google by second time, it will only be there only once, alright? So if you know sets from like your discrete math class or whatever, this should make sense to you, right? If you don't, that's okay, you should probably get it, right? You cannot have same values multiple times in a set, alright? And yeah, so that's only one thing I want to show you. Another thing that I want to show you is some methods that you can do with sets. So for example, if I type in here my set, and then I type in here the dot, there are a lot of methods that I can use. So let's start with the add method. What it does? Well, it adds something to the set, right? So for example, I want to add a Microsoft, like this. So if I run this right now, you should be able to see Microsoft at the end, right? Yeah, there it is. So that's how you can add something. All right. Then you can, for example, add multiple values. So for example, type my set dot update, and then you can type in there, then you can type in there a list of values. So for example, I don't know, orange, whatever, I don't know. So something, basically anything you want, alright? And if I run this, as you can see, there is the orange and some NSSS. And another thing that I want to mention is that this list is not ordered, alright? So it doesn't matter in which order the elements are, right? As you can see, the Microsoft was last when we printed it previous time, and right now it's second, right? So the order of elements doesn't matter, alright? That's why the indexing isn't working. Cool. So let me show you another thing that you can do. You can ask for the length of your set. So simply by typing len, and then you pass in there the set. Alright, so like this. And if I run this, you should be able to see 6, 1, 2, 3, 4, 5, 6. That makes sense. Alright, you can do the same stuff with the tuple variable and the list variable, but we will get to it later on. Alright, and yeah, so the almost last thing I want to show you is the remove, right? So what if you want to remove something? You can do that, right? You can do my set, and let's say that you want to remove a apple. So like this, right? So you basically add the parentheses and then you pass what you want to remove. And then if you print the set, there shouldn't be any apple, all right? There is no apple. Cool. And once again, as you can see, the orange was somewhere in here and right now it's first, right? So yeah, the order, there's no ordering. Alright, but the problem is that if you type in here something that is not in the set, so for example something like Apple 2, you will get an error. So if I run this, as you can see, there is a error, Apple 2 is not in the set, alright? And that's sometimes a kind of bad, right? Sometimes you are not sure whether something is in the set or not. For example, if user writes some value, then you add it to set, you are not sure whether the user wrote 10 or 5, right? So yeah, so then this method is kind of bad, right? So in order to solve that, you can use the mySet.discard method. Discard, like this. And in here, if you type something that is not in the list, you won't get an error. So if I run this, as you can see, it works, right? And if I type in here something that is in the list, so for example, the NSSS, and if I run this, it would delete the NSSS, alright? So it's basically the same as the remove, only this time, if you are trying to remove something that is not in the list, you will not get a error, alright? So yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask and I'll see you next time. Alright, so what is a tuple? Well, tuple is basically the same thing as list, only in tuple you cannot change the elements, right? So you cannot change the value of elements. So let me show you. For example, in here I will create a tuple variable, and I will define it like this, right? So you use parentheses and inside you write the elements. So for example, Apple, and then Google, and then stuff. Alright, like this, right? So we created a new tuple. Then what we can do is, for example, try to set the value on index 1. So same thing as before, right? And we can change it to, for example, DDD, whatever. And then we can print some element on index 1. Alright, so print tuple variable on index 1, right? So that's quite easy, right? You already know this stuff, but the difference is that we get a error. Okay, so why is that? Well, the tuple object, right, which is this tuple variable, right, it does not support the item assignment, right? So we cannot assign anything to it. So that is why we can't change any values that are stored in the tuple, right? So if I run this like this, it will work, right? So we print Microsoft, that is this code in here, and then we print Google, all right? So yeah, you can also comment this one out just to see only the stuff that we are working on. And as you can see, it says only Google, all right? And yeah, so that's the main difference between tuples and lists. In tuples, you have the same value. You can have same value multiple times in here. So for example, in here you type Google, right? And this will also work. Yeah, there is no problem in having same values multiple times. So for example, if I ask for the value on index 3, we will get the same result, right? Google. All right. So yeah, that's pretty much it for this lecture. The tuples works exactly same as sets, only you cannot change the value. Alright. Alright, so what is set? Well, set is another data structure, so basically a collection of variables, same as before. But this time you cannot index the variables, so you cannot use this thing. Alright, so let me just define a new set by writing, for example, my set, and then when you want to define a new set, you simply type in here the curly brackets, right? And I'll simply copy the elements and paste them in here, all right? And then what you can, for example, try to do is try to access some element on some index, right? So you can type my set and then index, like for example 0, and if you try to run this thing, it will get a error, right? Set object does not support indexing, so you cannot do that. And if you try to print the set, you can do that. So if I run this, as you can see, there's Apple, Google stuff. So why isn't there the other Google? Well, that is because the set does not support duplicates, okay? So you cannot have two values multiple times, or like you can have, you don't have a error, but if you try to add a Google by second time, it will only be there only once, alright? So if you know sets from like your discrete math class or whatever, this should make sense to you, right? If you don't, that's okay. You should probably get it, right? You cannot have same values multiple times in a set, alright? And yeah, so that's only one thing I want to show you. Another thing that I want to show you is some methods that you can do with sets. So for example, if I type in here my set, and then I type in here the dot, there are a lot of methods that I can use. So let's start with the add method. What it does? Well, it adds something to the set, right? So for example, I want to add a Microsoft, like this. So if I run this right now, you should be able to see Microsoft at the end, right? Yeah, there it is. So that's how you can add something, alright? Then you can, for example, add multiple values. So for example, type my set dot update, and then you can type in there, then you can type in there a list of values. So for example, I don't know, orange, whatever, I don't know, so something, basically anything you want, alright? And if I run this, as you can see, there is the orange and some NSSS. And another thing that I want to mention is that this list is not ordered, alright? So it doesn't matter in which order the elements are, right? As you can see, the Microsoft was last when we printed it previous time, and right now it's second, right? So the order of elements doesn't matter, alright? That's why the indexing isn't working. Cool. So let me show you another thing that you can do. You can ask for the length of your set. So simply by typing len, and then you pass in there the set. Alright, so like this. And if I run this, you should be able to see 6, 1, 2, 3, 4, 5, 6. That makes sense. Alright, you can do the same stuff with the tuple variable and the list variable, but we will get to it later on. Alright, and yeah, so the almost last thing I want to show you is the remove, right? So what if you want to remove something? You can do that, right? You can do my set, and let's say that you want to remove a apple. So like this, right? So you basically add the parentheses and then you pass what you want to remove. And then if you print the set, there shouldn't be any apple, alright? There is no apple. Cool. And once again, as you can see, the orange was somewhere in here and right now it's first, right? So yeah, the order it's there's no ordering. Alright, but the problem is that if you type in here something that is not in the set, so for example something like Apple II, you will get an error. So if I run this, as you can see, there is a error, Apple II is not in the set. Alright, and that's sometimes a kind of bad, right? Sometimes you are not sure whether something is in the set or not. For example, if user writes some value, then you add it to set, you are not sure whether the user wrote 10 or 5, right? So yeah, so then this method is kind of bad, right? So in order to solve that, you can use the mySet.discard method. Sorry, discard, like this. And in here, if you type something that is not in the list, you won't get an error. So if I run this, as you can see, it works, right? And if I type in here something that is in the list, so for example the NSSSS, and if I run this, it would delete the NSSSS, alright? So it's basically the same as the remove, only this time if you are trying to remove something that is not in the list, you will not get a error, alright? So yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask and I'll see you next time. Alright, so let's take a look at more advanced stuff that we can do with sets. So for example, if you have a class of discrete math, you probably know that you can do union and intersection, right? And difference. But if you don't, that's okay. So let me just show you how to do that in Python. So you simply type mySet, then dot, and you type in here union and the second set. So my other set, for example. And then if I run this, as you can see, it says Apple, stuff, Google, and FFF, right? Which are all the elements that are in both of these lists, right? So there are no duplicate values, right? Each value is there only one time, but they basically took these two elements from both sets and put them into one, alright? And yeah, so another thing that you can do is do the intersection, which is quite similar. And if I run this, you should be able to see what's the difference, right? The intersection basically takes the elements that are in both of these sets. So the element that is in my set and is in the my other set will be in the result, right? But for example, the stuff is only in my set, but it is not in the other set, so it will not be in the result. And as you can see, it is not, right? So that's basically the intersection. And another operation that you can do is the difference. So difference, and what it does, well, let me run the program so you can see. And as you can see, there's only stuff. So what it does, so for example, in here we have the my set, and it basically takes all the elements from my set that are not in the my other set, alright? So if you, for example, Apple is also in the my other set, so it will not be in the result, right? Google, same thing, is also in the other set, so it will not be in the result. But stuff is not in the other set, alright? So it will be in the result, and that's why we have only stuff in here, alright? So I think this should make sense. And another thing you can do is ask for whether it is a subset, you can do whether it is a disjoint set, right? But yeah, this is more kind of for the discrete math class than for the Python class, right? And here you can check for all the methods that you can do, right? So simply type dot, and then you can check, you have the update, union, right? There are a lot of methods, but we will talk about some of them later on in this course. Right now, the intersection, union, and the difference is all you need to know. Okay, so what for loop allows us to do? Well, in general, a loop allows us to repeat some set of instructions, right? To all over again the same code, alright? So loop, for example, allows us to print every element from a list, alright? So let's say that we got in here the list, companies, and in there we have 4 companies. And we don't want to do the stuff like print a companies on index, right? Sorry, companies on index 0, right? Then print the company on index 1, and so on, right? That's too much work. What we want to do is go for every element in the companies list, and for each element do the same set of instructions, and that means print the element, right? So in order to do that, we can simply do that using the for loop. So in order to create a new for loop, you simply write for, then you write, for example, some name of a variable, right? So for example, C as a company, then you type the keyword in, right? Then you write the list, so companies, and then you write column, right? And then same as if condition, you need to have the space in here, and then you do whatever set of instructions you want to do, okay? So for example, in our case, we will print C, okay? So when I run the code, you should be able to figure out what C is, right? C is just the iterator, right? It stands for every element that is in companies, right? We want to print it, okay? So for every C, that's the element in companies, we want to print it. As you can see, we go through Apple, Google, Amazon, and Netflix, all right? So that's basically the for loop. There's not too much about it. And another thing that you can do is, for example, loop through a string. So if you remember in previous lecture, I said that string is basically a set of characters, right? So you want to go, for example, character by character in a string. So you can do that. For example, you can do for, you can do like X or whatever in the string example, right? And then column. And then we want to, for example, print only the one character, okay? So there will be each character on one line, okay? So if I run this, yeah, as you can see, example, right? So, but each character is on one line, okay? Okay, and another thing I want to show you is that you can see these variables, this C and this X, outside these loops. So for example, in here, if I decide to print for some reason the C, what is in the C variable, I can do that. So simply type in print C, then run the program. And as you can see, it says Netflix at the end. Why is that? Well, the last value that was assigned to the C was the last element that was in the company's list, right? Which is Netflix, alright? So that's why it still have the value of Netflix, and you can even check it with the X, right? So if I type in here print X, it should be equal to E, alright? So if I run this, it says Netflix and then E, alright? So cool, right? That's another thing that you can do, and yeah, that's pretty much it for the for loops. You can have, once again, multiple instructions in here. So for example, if you want, you can print it multiple times for some reason. Not sure why you would do that, but yeah, in here all the characters are doubled, right? Just want to demonstrate that you can have multiple lines of code in here, right? Right, so the for loop is quite simple. For every something that is in something else, you do something. That was a lot of somethings, right? But I hope you understand it. It should kind of make sense because we do that usually in our real life, right? We want to iterate through some series of somethings, okay? So, yeah, I hope you understand it. If you don't, just ask me and I'll see you next time. Alright, so let's take a look at more advanced stuff that we can do with sets. So, for example, if you have a class of discrete math, you probably know that you can do union and intersection, right? And difference. But if you don't, that's okay. So let me just show you how to do that in Python. So you'd simply type my set, then dot, and you type in here union and the second set. So my other set, for example. And then if I run this, as you can see, it says Apple, stuff, Google, and FFF, right? Which are all the elements that are in both of these lists, right? So there are no duplicate values, right? Each value is there only one time, but they basically took these two elements from both sets and put them into one, alright? And yeah, so another thing that you can do is do the intersection, which is quite similar. And if I run this, you should be able to see what's the difference, right? The intersection basically takes the elements that are in both of these sets. So the element that is in my set and is in my other set will be in the result, right? But for example, the stuff is only in my set, but it is not in the other set, so it will not be in the result, and as you can see, it is not, right? So that's basically the intersection. And another operation that you can do is the difference. So difference, and what it does, well, let me run the program so you can see. And as you can see, there's only stuff. So what it does, so for example, in here we have the my set, and it basically takes all the elements from my set that are not in the my other set. All right, so if you, for example, Apple is also in the my other set, so it will not be in the result, right? Google, same thing, is also in the other set, so it will not be in the result. But stuff is not in the other set, all right? So it will be in the result, and that's why we have only stuff in here. All right, so I think this should make sense. And another thing you can do is ask for whether it is a subset. You can do whether it is a disjoint set, right? But yeah, this is more kind of for the discrete math class than for the Python class, right? In here you can check for all the methods that you can do, right? So simply type dot, and then you can check. You have the update, union, right? There are a lot of methods, but we will talk about some of them later on in this course. Right now, the intersection, union, and the difference is all you need to know. Alright, so let's take a look at the while loop. While loop is a bit of a different than the for loop. For loop usually iterates throughout like some sequence, right? Throughout some list, throughout some set, alright? But the while loop iterates while some condition is true. So it's basically like an if condition, but only this time, if the condition is true, we iterate throughout the whole sequence of commands, right? But then we go back up again and check for the condition again, and then we once again iterate throughout the whole process, and then we go back up again and once again iterate until the condition is while the condition is true. All right, when the condition is false, we don't iterate and we jump at the end and continue with lines down below. So let me show you an example. So if I define a variable called, for example, I, and I set it to 0, I can do this. So while I is, for example, smaller than 10, colon, and then I want to, for example, print I. So print I, like this. And then I also want to increment I. So I will set I equal to I plus 1. All right. You can also do this thing. So I plus equal 1. All right. Sorry, like this. But yeah, that's never mind that. So you can simply keep it simple and do this thing. All right. And then when I run the program, what do you see? You go from 0 to 9. So why is that? Well, computer goes to this while loop and figures out, all right, 0 is smaller than 10. So that's quite cool, right? He can do some commands. So then he goes to this line, prints I, and then he sets I as a I plus 1. So that means I is now 1, all right? And then he goes back up again to this while and once again check for the condition, all right? And I is now 1, all right? So I is still smaller than 10. So he prints 1, that's why in here you can see 1. And once again he increments I, alright, so that we can see 2. And we go all the way up to 9. Why can't we see 10 in here? Alright, well, think about it. When I is 9, alright, computer goes to this while and checks 9 is smaller than 10, right? That's true, that's true. So he prints 9, but then he increments 9. So he adds 1 to 9, that means I is now 10. So that means when he goes back up to this while and checks this condition, 10 is no longer smaller than 10, right? So he breaks out of this cycle and continues with instruction down below, and there aren't any, alright? And another thing I want to mention is that you can make the condition in the while loop much more complex. Why is that? So for example, let me just define a new variable j equal to, I don't know, -10. And we can also say that we want to loop while I is smaller than 10 and j is smaller than y. So yeah, you can make the condition much more harder, right? This one will not do anything. But if you, for example, will change that to while j is bigger than I and set j to, for example, 5, we will iterate only to 5, alright? So 0 to 4, right? To 5. And yeah, so why is that? Well, we have the end in here and j is equal to 5, so we are basically looping while I is smaller than 5. All right, so yeah, that's just to demonstrate how the condition can get a bit more complex, right? You can do that. You can, any condition you can fit into a if statement, you can fit it into a while statement, all right? And that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. In some cases, we want to break out of a while loop before, for example, this condition is met. So let's say that we are printing the companies, all right? So we are going from Apple, then Google, Amazon, and Netflix, all right? But let's say that we, for some reason, hate Netflix. I don't know why, but we hate it, and we want to stop when we are at Amazon, right? So Amazon will be the last company that we want to print, all right? So how to do that? For example, there are a couple of ways we can do it, but we can do it also via the break statement. So what break does? Well, it allows us to break out of a cycle, alright? So for example, we are iterating from some stuff, but the condition is still true, alright? So we want to break out when something happens, alright? So we simply tell the computer, okay, I want to break out no matter what this condition looks like, alright? So even if this condition is true, the computer will break out of this cycle, okay? So let me just show you. So in here, let's define a if condition, and then let's say the company on index I, alright? So the company that we are currently at, so the element in this list, companies, that we are currently at is equal to Amazon, like this. So if it is equal to Amazon, we would like to break out of this cycle. And how to do that? Well, we simply write break. So if I run this, and as you can see, alright, alright, let me just comment these two out so that you can see it better. And so like this. And if I run it again, you should be able to see only Apple, Google, and Amazon. Why is that? Well, we have the break statement. So how computer evaluates this while loop? Well, he starts at 0, okay, because I is equal to 0. I is still smaller than the length of our companies, right? The length of our companies is equal to 4, right, in our case. So we print the company, so we print Apple, okay? Then we check whether Apple is equal to Amazon. It is not, so we ignore this line and increment I, alright? Then we go back up again, and I is now equal to 1. It is still smaller than 4, so everything is alright. We go into this while loop, and then we print the company, which right now is Google. And we once again check whether the Google is equal to Amazon. It is not, so we ignore this line, and we increment I, alright? Then we go back up again. I is still smaller than 4, right? It's 2, because we have Amazon in here. And so we print the Amazon out. Then we check whether Amazon is equal to Amazon, and yeah, it is, right? It is. So then we break out of the cycle. And another thing is that the I should now be equal to 2, because this line will not happen. Okay, so if I print I like this, and if I run this, as you can see, it says Apple, Google, Amazon, and then 2, alright? Because this line will not happen because we break out of this while loop. So that means we end up at this line 10, alright? So yeah, that's basically how we can use the break statement. Another thing I want to mention is that if I put this break statement even above the print, so like this, what happens? Sorry, if I put the print back, print companies on index I, like this. So what happens? Will Amazon be printed? Well, it will not, because we go Apple, then Google, alright, everything is alright. Then we reached Amazon. So Amazon is equal to Amazon, and we break out of this cycle. So these two lines will not happen, and we will only print I. I will still be 2, alright? But Amazon is not in here, as you can see, alright? So yeah, this is the break statement. We simply get out of a loop. And it also works in a for loop. All right, so for example, if I just delete this thing and decided to go for companies, and inside here I can once again do something similar. So if a C as a company is equal to, for example, Google, I want to break out. So break, and as you can see, it should work. So yeah, I forgot about com in here. So if I run this again, it says Apple and Google. All right, so the C goes from Apple, then it goes to Google, and Google is equal to Google, right? So we break out and we ignore Amazon and Netflix and continue with these lines. And another thing that I want to show you is the continue statement. With the continue statement, we can stop the current iteration and continue with the next one, all right? So, for example, if I put in here if the company is equal to, I don't know, for example, Apple, all right? So right from the start, we want to continue. So as I said before, we stop the current iteration, so we stop in here and continue with the next one. So we go from here, we go straight up to this 4, all right? So the instructions down below, so that means only this print, will not happen. So if I run this, it should say Google, Amazon, and Netflix because Apple is skipped, all right? So I can put once again more complex conditions. So or C is equal to, for example, Amazon. So like this. So if I run this again, you should be able to see only Google and Netflix, right? Because the condition was met 2 times, one for Apple and then for Amazon, all right? And when this condition is true, we skip the remaining part of the for loop, all right? So that means this print, and we go straight up to this 4 and continue with the next element, okay? So that's what continue allows us to do. Alright, and another thing I want to show you is that the continue statement works also for the while cycle. So if I define, for example, a simple while cycle like while I is smaller than 5, I would like to increment I, right? So I plus equal 1, and then I would like to check whether I is equal, let's say 2, and if it is, I would like to continue, alright? And if it is not, I would like to print. So print and then y. All right. So if I run this, you should be able to see 1, 3, 4, 5. All right. And that's exactly what do you see. Why is that? Well, we start at 0. All right. Then we increment I. So I is now 1. We check for this condition. It's false. So we skip this continue and we print 1. Okay. Then we go back up again and see that 1 is still smaller than 5, right? So this is true. Sorry, this is true. And then we check for then we increment I, all right? So I is now 2. And we check for this condition, and 2 is equal to 2. So we go and execute this continue. That means we skip the rest of the loop, all right? So it will not be printed. And we go straight up, and I is now 2, okay? And then we continue. So I plus equal 1, that's 3. And this condition is not met, and we print. And the same thing happens for 4, and same thing happens for 5, okay? So yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask, and I will see you next time. Alright, so what is a dictionary? Dictionary is basically something like a list or something like that, but inside we have pairs, and each pair is made up from key and value, alright? So let me just define one dictionary. I think you will understand it better on an example. So dictionary and dictionaries, whatever, yeah. And inside here, when we want to define a dictionary, we write curly brackets, and then inside them we write the pairs, alright? So each time we write key and the value of that key. So for example, key can be something like a brand, alright? So let's call this one, for example, a items, okay? And we will have a brand, then we write column and the value for the key, okay? So for example, it can be like apple, okay? Then we write comma, and on the next line, we can write, for example, a model. So like this, model. And then we write, for example, I know X, then we write, I know year, okay? You can do whatever you want, right? And inside here we write, for example, 219, okay? And yeah, so then what we can do is, for example, print it. So print the items like this. And if I run this program, you should be able to see all the items, right? So there are these pairs, right? Separated by comma, okay? Alright, but how do you access an item? Okay, how do you do that? Well, do you remember list? And we had the indexing, right? So this thing works similarly, but instead of the indexes, we have the keys, right? So this brand, model, and year. So for example, if I define a new variable called temp, and in the temp variable, I want to store the value of a item, and in there, for example, the brand, okay? So the value that is in the brand pair, okay, which should be Apple. And then I can print it like this. So if I run this, as you can see, it prints Apple, right? Because Apple is the value of the pair where the key is brand, okay? And it works the same, but for, if I comment this line out and write in here the get, so if I type in here items.get, and then I pass the brand, so like this, okay, and inside here we pass the brand, and if I run this, it still says Apple, okay? So these two are the same, okay? Cool. Another thing that you can do is, for example, change a value for a particular pair, okay? So for example, let me say that I want to change the year to 220. So if I, for example, type in here the items, and then in square brackets, I type in there the year, and then I assign a new value, so 220, like this. And then if I want to print the whole dictionary, if I run this file, as you can see, it says 220, okay, 2020. So it works basically the same way as a list, only this time instead of indexes, we have the names, so the keys, okay? So another thing that we can do is loop through a dictionary. So for example, if I want to define a new for loop, and inside here I want to loop through every item in items, so basically through every key in items, in the dictionary items, and I want to print the key. So if I type in here print X, if I run this, so run Python file, and as you can see, it says brand, model, and year. So the X in items basically means go for every key in the dictionary items, okay? So how do we get the values? How to do that? Well, we can index it. So in here I type items, and then on index we write key, right? So the index is key, okay? And if I run this again, it should say Apple, X, and 2020. Okay, so these are the values, okay? But still, if you want to do it differently, you can do that. Simply in here, type items.values, and then parentheses. And that means we go for every value that is in the items dictionary. So that means Apple, X, and 2020, right? Because we changed it in here. So if I get rid of this stuff and run this, it says the same thing as before, okay? Cool. Okay, that's quite cool, right? You gotta admit. But I would still like to go through the key and the value at the same time, right? So I would like to have something like X and Y in here. And then I would like to go through every pair. So in the X, I would have the key, and in the Y, I would have the value, okay? So how do I do that? Well, you can also do that. Simply in here, type items. So items.items, for example, let me just rename this to item, okay, so that it looks quite better, right? You type .items, and this will return a pair. So if I, for example, then type in here print X and Y, like this, so I can do that. So if I run this, as you can see, it says brand, Apple, model, X, and year 2020. So yeah, that's another thing I maybe did not mention. You can print multiple variables at the same time using the comma in here, right? As you probably noticed. Alright, so another thing that you can do is check whether something is a key in the dictionary. How do you do that? Simply, for example, by writing if, and then, for example, type brand is in the dictionary. So that means item, right? Then you write colon, and for example, we print something like Yes. Yes. Sorry, yes. And if I run this, as you can see, it says yes, right? Because brand is obviously in the items, right? It's right here, okay? And yeah, so it's basically the same as if when we checked whether a element is in list, right? Only this time we are checking whether a brand is in dictionary, okay? Alright, but what if I want to check whether a value is in the dictionary, right? So right now we are checking only for the key, but what the value? Well, I can also do that. So for example, if I want to check whether X is in the dictionary, I can type in here, if X is in item.values, so same stuff as before. So the item.values basically allows us to access a list of values that are in the dictionary, okay? I hope that makes sense. So then if I run this again, you should be able to see the brand and the yes, okay? So yeah, cool. But then you might think, what if I want to add a new item, okay? So what if I want to add a new pair to this item dictionary? Well, I can do that. For example, simply by writing in here the item, then the square brackets, and for example, something that is not in the dictionary. So something like price, okay? And I can set the price to like $2.99, $1,099, yeah, whatever. So if I now run the program, you should be able to see the price in there, right? At the end, there is price. Cool, right? And same goes for deleting. So remember how we deleted an element from a list? The same thing goes for dictionaries. So if I want to delete, for example, a item where the key is, I don't know, year, right? So I want to delete the year. I can do that simply by writing like this, and then I will print the items again. Sorry, item, so that you can see it. And if I run it, as you can see, the first one, that's this print on line 9, prints the price and the year, but the second print deletes the year, okay? We cannot see any year in here, okay? Cool. And that is pretty much it for this lecture. Alright, files are used in pretty much every application, right? You have some text editor, right? You can save the file, you can open the file, you have like a, I don't know, video player, right? You open a video file, right? So pretty much every application uses files in some sort. So it is important to know how to do that. So first of all, we have the open function. And what this function does? Well, it opens a file for you so that you can write into it and that you can read from it, okay? And so it takes few parameters like file, which is just a path to your file. So for example, something like C, you know, it can be absolute path, so some folders in here, or it can be also a relative path. So when you run your application, the application is located in some folder, right? And if you use a relative path, you basically can create a file in the location where your executable file is running. Okay, so where the location of your file, of your program is, okay? So for example, let me show you that. So as you can see, the files is in some directory called code, okay, that I have opened in here. And if I, for example, want to create a new file and then write something into it, I can do that. So for example, in here I type the name of my file and the name of my file only. I don't necessarily have to write the path in front of it, right? So that's the difference between the absolute path, where you need to write everything from the C and so on, to the relative path, right, where you write only the name. So my text file .txt, for example, and then you write the mode. So basically in here you define what you want to do with the file. So there are a couple of options. The first one is that you want to create the file, which is X, okay? So the first letter stands for what do you want to do with the file. You can open it, you can read from it, you can write to it, or you can append the file, okay? And the second letter stands for the type of file. So we have two types. The first one is a text file. So for example, something like just a text file. You can think of it as a file that you create in your Word, okay? So or in any other text editor. Or you have a binary file, which is, for example, a image, right? Image is a binary file. And yeah, so for example, let's say that we want to create a text file. So then we type in here the T, okay, and if we want a binary file, we will type in here B, alright? So this one will be text file. You also, the text is a default option, alright? So you don't necessarily have to write it in here, okay, but I will just leave it in there. And obviously right now we simply opened a file, but we have no way to work with it, right? We didn't store it anywhere in our memory. So we will create a new variable called, for example, f, and we will assign it to the value of the opened file, okay? And then we can do all kinds of stuff. So for example, we can write into the file. So f.write, and then we pass in there some string, so just few a's, okay? And if I, for example, run the program right now, nothing is printed, right? But as you may notice, in here is my text file, alright? And so that's this file that we just created. And if I double click it, it will open up in my editor, and as you can see, there are the few a's, okay? So yeah, that's quite cool, right? It's simple as that. You simply use the open method in order to open the file, then you define the mode, so basically what you want to do with the file, and then you can use all kinds of fancy stuff in here. Alright, so I will talk more about it in the following lectures. Alright, so in this lecture I will talk about how you can write into a file or how you can append a file. So if you are not sure what that means, so write basically means that you open a file, then if you want to write, you basically delete all the content that was in the file before you open it, okay? So in some cases you want that, but in most cases you would like to extend the file, right? And write at the end of the current file, which means append, right? So you basically open the file and you start writing behind the current content, okay? So yeah, so let me show you how you can do that. First of all, in here, as you can see, we define the mode, right? As you learned in previous lecture. The T is default, so we don't necessarily have to write it in there. And the X stands for create a new file. And what I forgot to mention in the previous lecture is that when you try and open up a new file that is already created, so for example, I will type in here something that I want to write, like whatever, right? Okay, so currently it is AAA, the file. But my point is that I already created the file, right? As you can see in here, it says AAAAA, but I want to create it again with this X. So what will happen? Well, if I run this file, I will get an error, right? File exists error. So what that means? Well, you can only use this X if the file doesn't exist, right? If this file exists, you cannot use the X, you will get an error if the file exists. So yeah, but let's go to the writing. So if you want to write, you simply type W like this, and if I run this program right now, it works just fine. And if I open the file, as you can see, it overwrote the AAA and wrote the stuff that we added in there, okay? So if I go back to files, as you can see, there is just DDFDDD. So if I, for example, change it once again and run this again, it should be changed once again. So if I go to this file, as you can see, it's JJJ, alright? Cool. So another thing that I want to mention is that you can write multiple times. So for example, in here, I would like to also write something, and yeah, so if I run this, the file is changed, and as you can see, it says JJJJ and then GGG, alright? So yeah, so now you may ask, what if I want to end the line? Alright, so how do you do that? Well, you can use one of the escape sequence. So for example, this one. So this one will end the line, alright? So for example, if I add some text down here and run the program, this JJJ will be on the next line. So if I look at the file, as you can see, it is on the next line. And you can do much more stuff. So for example, you can use a tab, right? So you can type a tab inside here. So if I run this, right, as you can see, there's a space and between these two, all right? So cool, that's what you want to do. But let's say that I would like to append the file, right? So the thing is that I always override the file when I run the program. So let's say that I want to simply open the file and then start writing at the end of the file, right? So simply extend the file. And in order to do that, I simply change this write, so the W to A, and as a append. And if I run this, as you can see, it works just fine. So you use the same method. And when I open the file, as you can see, it starts typing from here. All right. So yeah, so this is the lines that we wrote when we execute the file. All right. So for example, if I change this only to GGG, and if I run this program again, as you can see, it typed these 4 G's again. So if I run this once again, so that you are absolutely sure that I'm not lying, yeah, there are another 4 G's, all right? So yeah, that basically, it keeps the file the same and then types something other to the end of it, all right? So yeah, that's basically how you can write something into a file. Alright, so let me show you how you can read a file. So usually you write something into a file and save it, right? So as you can see, we have the file in here. But then you want to open it up and read the actual content. So in order to do that, you need to specify the parameter, right? So inside here, you type R as a read, alright? And then you can use the read function in order to read the file. So for example, if I want to print it out, I can print it out using a f.read and then parentheses. And if I run this program, as you can see, it prints the whole content of the file, right? Okay, they are the same. So cool, right? So another thing that you can do is specify the number of characters that you want to read. So for example, let's say that I want to read only the first 4 characters. So that means these 4 J's. I can simply do that simply by typing in here the size of the characters that I want to read, so 4. And if I run this, as you can see, there's only the JJJJ, alright? So quite cool, right? And another thing that you can do is read the file line by line, alright? So instead of this read, you can write in here a read line, so read line. And yeah, parentheses. And if I run this, as you can see, there is the first line printed, right? So that is quite cool. And you can use this method multiple times. So for example, if I read line again, I will read the second line, all right? So if I run this, as you can see, there is the first line, all right? So in here is the actual content of the file, right? So that's the first line. And the second line have more G's in there, all right? And yeah, so that's this one. And if I want to read the entire file, I can put it there, the third read file statement. And if I run this, sorry, read line. And if I run this, as you can see, there's the last line. Cool. So another thing that you can do is simply go through the file via a loop. So as you might remember, we learned about the for loop, right? So for example, in here, you can type something like for line in the F. All right, I want to print it. So I would like to print every line like this. So if I delete this stuff and run this program, as you can see, it is exactly the same. All right. So this is the same as before the free read line statements. So yeah, that's quite cool, right? You can read a file, you can do a writing, you can right now you can basically work with files. So yeah, if you have any questions, feel free to ask and I will see you next time. Alright, so you know how to open, how to create, and how to read, and how to write. Alright, but you don't know how to delete. So how do you delete a file? Well, deleting is a bit harder. So for the opening and stuff like that, we only dealt with the open function, right? So it was quite simple. Only in here we defined what we want to actually do with the file, right? So the deleting is not so easy, but it is also not complicated. So let me show you. First of all, when you want to delete something, you need the help of your operating system, all right? And in order to add the the functionality, right, the sum of the functionality of your operating system, you need to import the operating system. So simply type in here import OS. And what that means? Well, basically this line tells the computer, hey, I would like to use the OS module, right? So yeah, then you can use all the modules from the OS. So for example, OS dot, then for example remove, and then you specify the name of the file. So for example, the my text file. All right, so let's remove the file that we just created. So text file .txt, and if I run this, it runs and the file is deleted, right? So yeah, that's quite cool, right? So that's how you can remove a file. And if I, for example, want to, I will just create this file again. So create, and yeah, then we also need to, for example, write something in there. So write, and yeah, let's write something. But yeah, so if I create is via X. So if I create the new file again, I can do that, right? The file should be created. Yeah, there it is. And then I would like to remove it, but I would like to first of all check whether the file actually exists, right? So that's usually what you want to do. You want to check whether file exists, and then if it exists, you want to delete it, right? But if you, for example, if I type in here something that does not exist, all right, so some file that is not existing, I would get an error, right? So I need to check for this. And in order to check for it, you can simply type in here, for example, an if statement. So if os.path, right? So what do you want to check? Whether it exists. So you type path exists, and then you type in here the path. So for example, my text file. So my text file.txt. All right, so this one will check whether the file exists, and if it exists, we would like to remove it. All right, and if it does not, we can, for example, print something. So else we would like to, else we would like to print the file does not exist. All right, so if I run this file again, it will work, right? So yeah, sorry, I'm creating a file that is already being created, right? So I will comment these two lines out and run it again, and as you can see, we deleted the file. And right now, why did happen? Well, because the file existed, right? But this time the file does not exist. So what happens if I run this again? It will print the file does not exist. Okay, so in order to delete a file, you need the OS support. So you need to import the OS module, and then you can, for example, check whether the file exists. If it does, you can remove it. If it doesn't, you can print something to the user to let him know that you cannot delete the file. And another thing that you can delete is the directory, right? So for example, as you can see in here, I have the temp directory, so let's delete that. Simply type in here OS, then dot, and then you want to delete the directory, or in other words, you want to remove the directory. And by short, you type ram as a remove, and then dir as a directory. And then you type the name. So in this case, it's the, temp, not test, but the temp directory, as you can see in here. And if I run this program again, it should delete the directory. And as you can see, it is deleted. Right, so that's quite cool. That's how you can delete files and directories. And yeah, if you have any questions, feel free to ask, and I'll see you next time. So as you know from previous lecture, if you're working with files, some error can occur, right? So for example, you want to create a file that already exists, right? Or something like that. You get an error. So you would like to try something out. So you would like to try to create the file. But if the file already exists, you don't want to end the application, right? You would just you want to just print something, or you just want to work with the file, right? You want to, for example, read the file only, or whatever, right? So you don't want the application to crash via some error. So in order to do that, in order to try to do something, you use the try statement. So simply type in there the try, then the column, and inside there you type all these statements that you want to try. So basically in here will be the code that can result in some error. Okay, so for example, the open of the file. So for example, in here I will type just test.txt, and in there I will type that I want to create the file, and then I would, for example, want to write something in there, and that can be just whatever, right? But when I am working with these files, the error can occur. So what happens if error occurs? Well, in here we have the except clause to handle that. So inside here, we basically type the code that we want to execute if an error occurs when we try to do these statements, alright? So for example, in here we can just print a error, okay, or whatever, right? So if I run this program right now, it should just work, right? Because the file does not exist. So yeah, there is a new file called test. But if I run this again, alright, so if I run this again, we get this error, and then it's just one type of error that you can get, right? You can also get another error. So for example, if you type in there a variable that does not exist, right? So for example, we don't have any variables in here. So if I, for example, want to print, I don't know, an x, the x does not exist, right? It's not any variable in here. So we will once again get an error. So if I run this, as you can see, there is the error, all right? But, so if I, for example, comment these two lines out, right, we still get the error, all right? But how do we decide which error took place? Well, we can do that. So we would like to, for example, handle this kind of name error differently than the file opening error, all right? And that makes sense, right? Sometimes you want to handle different errors differently. So how do you do that? Well, simply inside, behind the except, you type the name of the error that you want to handle in this file scope, all right? So for example, it can be a name error, all right? So if I run this again, we get the error, and I can, for example, type in here the name error so that you can see it, all right? And then you can define another except, for example, for the file. So if I type in here the except, and then like file already exists, yes, so file already exists error, and then I can print the, I don't know, file exists. And if I run this, it says file exists. So why is that? Why there's not printed the name error? Well, computer evaluates this block like this. So he goes and sees this try. So he says, all right, I can try this stuff, and if something happens, I call these two, okay? And so he tries to open the file, all right? And he sees that the file already existed. So he raised an exception, all right? So basically, exception means that something happened that was not planned, all right? And then the exception name is file exists error, all right? So he looks at these excepts and sees that this one is for name error and this one is for file exists error. So he calls this one and executes the lines inside here, all right? So yeah, that's how you can define the except. And for example, if you want to just define a general except, right, you can do that simply like this. So except, and inside here you can, for example, print just the error, all right? So for example, you don't know what causes the error, but you know that the error happened, right? So if I run this, as you can see, there is only the file exists. So this is basically like an if statement, right? It executes only the body of this except, right? And then it skips the excepts below, all right? Cool. And another thing that you may want to do is use the finally statement. So what that means? Well, if you try something out, no matter whether that works or whether that ends up in a exception, right? So whether you get an error, no matter what, it will always execute some part of code. So for example, that is useful if you want to close a file, right? So no matter whether you can read or you cannot read, you want to close the file so that other programs can use it, right? So that's usually in the finally statement. So inside here you type the finally and then simply the colon. And in there you can define what you want to do at the end of this try clause, right? So you usually want to, for example, close the file, alright? And yeah, you also need to be careful about whether the f is not undefined. So for example, if I run this program right now, it will be not defined, right? Why is that? Well, because we didn't open anything, right? This open call caused a exception, alright? So we can, for example, inside here, use the write so that we want to write into the test file. And if I run this again, it works just fine, only this time we get the name error, but we close the file. So if I, for example, print in here something like end of try, right, I can do that. So if I run this, as you can see, it is executed even though we get the name error inside here. Okay, so and that's another thing that I want to mention is that the error, this exception handled the name error, okay, so that it actually works. And yeah, so another thing is that if I delete this line, this code will work just fine, alright? So none of these exceptions will take place and we will still execute the finally. So if I run this, as you can see, it still says end of try, and so that means it closed the program, it closed the file also, right? So yeah, this is basically the try except clause. And yeah, in here you can do all kinds of fancy stuff. I recommend using this a lot. You can handle errors. So sometimes in your program you are just not sure whether somebody is using the file that you want to read from, alright? So you need to be able to handle the error that somebody is using it, and you can do that via the try and except clause, alright? So yeah, if you have any questions, feel free to ask and I'll see you next time. So how do you use functions in Python? Well, first of all, you need to define a function, right? So you type in here define and then the name of the function. So for example, my function, like this, and then parentheses, alright, and then comma, and inside here you type all the instructions that you want to execute. So for example, I don't know, print and function called, alright, okay, like this. And yeah, so then what I can do is, for example, call the function. So this is basically how you can define a function. It's not so complicated, right? So you have the keyword, then you have the name, parentheses where you define the arguments, right? So we will get to it later on. Then same stuff as before, right? There's the tab, as you can see. And yeah, so then I can, for example, call the function. So my function and parentheses. And that's how you call a function. So if I run this, as you can see, it says function call. And the cool thing is that I can call it multiple times. So for example, if I decide that I want to call it for a second time, I can do that. And there will be two functions called, right? So that's one and there's two. So yeah, that's how you can define a function and that's how you call a function. Pretty cool, right? So another thing that you can do is, for example, pass an argument and parameter. So for example, and let's say that we want to pass a x, alright? And then we would like to print it with the function called. Okay, so in here we can then, so this is basically the parameter and we can refer in the body of the function to this parameter, alright? And how do we define what value will be stored in this parameter? Well, we pass it in here, okay? So whatever we type in here will be stored as a value of this x, alright? And you can type in whatever, function called 1, alright? Then I will call it 2, alright? And if I run this, as you can see, the output changed depending on whatever we passed in here, alright? And it makes sense, right? So this parameter it's binded as a value of the x, and the x is basically a variable, alright, nothing more. So this is basically a variable, and then we print the value, alright. So as you can see, it says 1 and then it says 2 in here. So yeah, that's quite cool, right? But another quite cool thing that we can do is define a default value for the x. So for example, I can assign it to, let's say, 0, alright. And why that can be useful? Well, sometimes we don't want to define all of the parameters and we would like to use some default value, right? So something like this. And then what we can do is call my function without any parameters, and this default value will be set as a x, alright? But if we pass a parameter, this default value will be override by x, alright? So if I run this, you should be able to see function called 1. Why is that? Well, we passed 1 inside here, so it deleted the 0 and set it as a value of x, and then we printed, right? Same goes for 2, but then we didn't pass any value, and since we have the 0 in here, we didn't get an error, and the value of x is equal to 0. Quite cool, right? So if I remove this thing and run this program, let's see what happens. Well, we get an error, right? Because we have a required argument x and there is no value in here, alright? But if we set it to the default value, we are alright. Cool. Alright, so in the previous lecture, we talked about how you can define a function, right? And how you can call it, but we didn't actually talk about that the function can return some output, alright? So let's talk about it now. So let me just define a new function that will be just out function, okay, whatever, and it doesn't necessarily have to accept any arguments. And then it can, for example, just return 10, alright? And that's it. So if I, for example, right now want to print the result of our function, right, so of the our function call, so remember the parentheses when we want to call a function, I can run the program and it says 10. Why is that? Well, we call this function and it returned 10 as a result of the function. Okay, so instead of this our function, it's actually saying 10, alright? And yeah, that then got printed, alright? So that's not a rocket science. You can, for example, add an parameter in here and, for example, return like 10 times x, and in here you can, for example, pass 5. So if I run this, it says 50, right? And if I, for example, call this one again with a 3, yeah, whatever, and I run it again, it says 50 and 30, alright? So yeah, that's how you can define a output of a function. And another cool thing that you can do is, for example, do a branching. And yeah, so let me show you an example. You can do, for example, if x is equal to 0, we want to, I don't know, print a error for some reason, and then we would like to return 0, okay, or just 1, whatever. And yeah, and in other cases, so in other cases else, we would like to return the 10 times x, okay? So I'm not sure why you would do that. For example, you need the function to return a positive number that is greater than 0, alright? So yeah, might be that. But anyway, so that should be a different condition, by the way, but never mind. So if I run this, what happens? Well, 5 is alright. Well, the x is 5, so 5 is greater than 0, and that means we return 50, alright? Same goes for 3, but then we call it with 0. That means this condition is true, so we print error, as you can see in here, and then we return 1. So as you can see, this 1 in here. So yeah, so that's the 1 is placed instead of this function call, right? And another thing I want to mention is what happens when I do it like this. What will be the result of the last function call? So let me just talk you through it before I run the code. So we pass in there 0, alright, so x is 0. So that means this condition is true, right? And then we print the error, and then we return 1. But then underneath, we continue with instructions underneath, right? Or we should. But actually no, right? We return the 1, and that's the end of the function. So this is like a break statement from a loop, only this time the return breaks out of the whole function, alright? So any instructions underneath the return statement will not be executed, okay? So it will be just exactly the same as before, okay? As you can see, the error, then 1, and this thing was not executed, alright? So it's just returned 1 and placed 1 instead of this function call, and then the 1 got printed, alright? So yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. So how do you use functions in Python? Well, first of all, you need to define a function, right? So you type in here define and then the name of the function. So for example, my function, like this, and then parentheses, alright? And then comma, and inside here you type all the instructions that you want to execute. So for example, I don't know, print and function called, alright? Okay, like this. And yeah, so then what I can do is, for example, call the function. So this is basically how you can define a function. It's not so complicated, right? So you have the keyword, then you have the name, parentheses where you define the arguments, right? So we will get to it later on. Then same stuff as before, right? There's the tab, as you can see. And yeah, so then I can, for example, call the function. So my function and parentheses. And that's how you call a function. So if I run this, as you can see, it says function call. And the cool thing is that I can call it multiple times. So for example, if I decide that I want to call it for a second time, I can do that. And there will be 2 function called, right? So that's 1 and there's 2. So yeah, that's how you can define a function, and that's how you call a function. Pretty cool, right? So another thing that you can do is, for example, pass an argument and parameter. So for example, and let's say that we want to pass a x, alright? And then we would like to print it with the function called. Okay, so in here we can then, so this is basically the parameter, and we can refer in the body of the function to this parameter, alright? And how do we define what value will be stored in this parameter? Well, we pass it in here, okay? So whatever we type in here will be stored as a value of this x, alright? And you can type in whatever, function called 1, alright? Then I will call it 2, alright? And if I run this, as you can see, the output changed depending on whatever we passed in here, alright? And it makes sense, right? So this parameter is binded as a value of the x, and the x is basically a variable, alright? Nothing more. So this is basically a variable, and then we print the value, alright? So as you can see, it says 1, and then it says 2 in here. So yeah, that's quite cool, right? But another quite cool thing that we can do is define a default value for the x. So for example, I can assign it to, let's say, 0, alright? And why that can be useful? Well, sometimes we don't want to define all of the parameters and we would like to use some default value, right? So something like this. And then what we can do is call my function without any parameters, and this default value will be set as a x, alright? But if we pass a parameter, this default value will be override by x, alright? So if I run this, you should be able to see function called 1. Why is that? Well, we passed 1 inside here, so it deleted the 0 and set it as a value of x, and then we printed, right? Same goes for 2. But then we didn't pass any value, and since we have the 0 in here, we didn't get an error, and the value of x is equal to 0. Quite cool, right? So if I remove this thing and run this program, let's see what happens. Well, we get an error, right? Because we have a required argument x and there is no value in here, alright? But if we set it to the default value, we are alright. Cool. Alright guys, in this lecture things will get a bit more complicated because we will talk about something called recursion, and this is one of the main subjects of a computer science, but it's quite hard to understand for the beginners, alright? So try your best, but you know, if you don't get it, it's okay. Like I also got a lot of problems understanding recursion when I started programming, alright? So it's okay if you don't understand it. So yeah, let me just define a factorial function. So the example that I'm going to show recursion on is a factorial of n. So you probably know this from your math class where you have like basically the factorial of n is equal to n times n minus 1 all the way down, right, times n minus 2, alright, and then all the way down to 1, alright. So for example, the factorial of 4 would be equal to 4 times 3 times 2 times 1, alright. So this will be the result, and this is great for recursion because what we are doing is actually calling the factorial with 4 times the factorial of n minus 1, right? Of 4 minus 1, which means 3. So yeah, let me just define the function. So factorial of n, and then what we want to do? Well, we end the line, so the ending condition is a n equal to 1, right? So if n is equal to 1, we end the algorithm and return 1, alright? But if it is not, we return the we return the n times factorial of n minus 1, right? Because that's what we have in here. Factorial of 4 is actually equal, right? So let me just write it in here. The factorial of 4 is actually equal to 4 times the factorial of 3. Why is that? Well, because factorial of 3 is equal, you wouldn't guess that, but 3 times factorial of 2. And factorial of 2, you probably get it by now, but I'm just gonna write it all the way to 1 is equal to 2 times factorial of 1. And then when we call the factorial with 1, we get the result of 1, right? Because the n is equal to 1, so that means this condition is true, and we return 1, alright? So what happens then? Well, right now, when we compute the factorial of 2, computer doesn't know what the factorial of 1 looks like, right? He only knows that this is a function call, so that means this is the factorial of 1 in this example, right? So, but now, by now, he knows that it returned 1, right? So he simply overrides this f of 1 with 1, alright? And then do the same thing with the factorial of 2. Right now, he knows that he have 2 times 1 in here, so he knows that the factorial of 2 is 2, right? So he writes instead of this factorial of 2, 2. And then he knows what the factorial of 3 looks like, because we have 3 times 2, which means 6, right? So he just places this 6 instead of this function call, right? And then he get like 4 times 6, which is 24, I guess. And that's the result of factorial of 4, alright? So if I run it so that you believe me, so print factorial of 4, it should say 24. So if I run this, as you can see, it says 424. So yeah, just the computer evaluates this thing, same thing as a human, as I wrote in here. So factorial of 4, which means n is equal to 4. We go to this condition, it is false. So we return 4 times the factorial of 4 minus 1. So that means factorial of 3. So that's exactly what I wrote in here, right? Yeah. And then computer would like to return a number, right? But computer doesn't know what the factorial of 3 looks like, right? So he first needs to compute the factorial of 3 before he returns the result. Alright, so this is really important. He needs to compute the factorial of 3 before he returns the whole result. Alright, and that makes sense. So that means he calls this factorial functions with 3. And what happens in here? Well, 3 is not equal to 1. So we return 3 times factorial of 3 minus 1. So that means factorial of 2. And that's exactly what I wrote in here, right? And once again, same thing. Computer doesn't know what the factorial of 2 looks like. He only knows that this is a function call. So he needs to first compute the factorial of 2, and then he can return the whole value, right? So then he calls the factorial with 2, and as you can see, 2 is different than 1, and once again he returns 2 times factorial of 2 minus 1, which is factorial of 1. So that's exactly what is wrote in here, alright? And then he calls the factorial with 1, and as you can see, the n is equal to 1, so 1 is equal to 1, so he can simply return 1 as a result, alright? And then the computer knows what this factorial of 1 looks like. It's 1, right? So yeah, then he starts to figure out what these results are, and he can finally give me the final number. So yeah, that's the recursion. If you don't understand it exactly, that's okay, but yeah, at least try your best. Maybe watch the video again, and if you still don't get it, maybe ask me a question, and yeah, I will do my best to explain it to you. So yeah, that's pretty much it. Alright, so in this lecture I will go a bit more through how the recursion works, and what we will do is step the program. So I will put a breakpoint in here. So that means you can put a breakpoint when you click somewhere in here, and as you can see, the red button stands for the breakpoint, or red circle, sorry. And yeah, so that means when the code goes to this line, it will stop, and I can take a look at the value of n and everything, alright? So yeah, and if you understand recursion, or if you think you understand recursion, I still recommend you at least watch a bit of this video so that you are absolutely sure that you understand it, alright? So yeah, simply put a breakpoint somewhere in here or on the line 17, and then press F5. So what will happen? Well, computer will run the program, but as soon as you reach the line 17, he will stop the execution, as you can see right now, alright? So the program just stopped, and I can take a look how the variables looks like and everything that is happening in the program, alright? And I can step the line by line, alright? So right now, as you can see, we are on the line 17, and it also tells me that n is equal to 4. You can also figure that out if you hover over the n, it says 4, right? And yeah, so if you hover over any variable, it will tell you that the value of the variable is equal to something, alright? So that's quite useful. So right now the n is 4, and that makes sense because we call the factorial with 4, right? So the n is equal to 4, right? And so this condition, 4 is equal to 1, is false, right? So if you want to step into the next instructions, you can do that by this button. And as you can see, we jumped inside here because we have the else branch, and since this condition was false, we get to this line. Cool. So yeah, inside here, as you can see, n is still 4, and we trying to multiply the n by the value of factorial of n minus 1, so that means 3, right? Exactly what I wrote in here. And yeah, so another thing that you can do is simply step over, alright, and that means if you click on this button in here, it will basically return the whole result of this function, and it will return just 24. But we don't want that. We would like to see how the function call ends up, alright? So you simply click on this step into, that means step into the function call, alright? And we will see how the function call looks like. So as you can see, n is equal to 3, and we get once again to this line. and then as you can see 3 is not equal to 1, so we step again and we reach this line once again. So we are returning 3 times the factorial of 3 minus 1. So that's exactly what I wrote in here, right? 3 minus 1 is 2. So if I once again step into the function, I can see that n is now 2, so we are calling the factorial of 2, because computer needs to compute the factorial of 2 before he can return the whole result, right? So he goes like 3 times some function call, and he figures out, alright, but I need a integer value, right? I cannot multiply a number by a function call. What would be the result of that, right? So he calls the function and waits till the function returns value, alright? So yeah, so that's the function call, and right now the n is 2, so that's different. So we can once again step to the next line, and as you can see it returns 2 times 2 minus 1, so factorial of 1, alright? And if I step in here once again, n is now 1, so that means this condition is true. So if I step in, we return 1, alright? So we stop the recursion. So this is the ending condition of the recursion, and we stop the recursion, and now we returned a value. Alright, so what we are going to do now is step out of this function. So yeah, that basically takes us to the function call, alright? So to the place where the function got invoked, alright, when the function got called. So that means this place, right? So if I click on this arrow up, we get to this point, and in here, as you can see, if I hover over it, it shows nothing, but this is basically 1, alright, because we returned 1, alright, and then we have n equal to 2. So we are returning 2 times 1, which is 2. And if I step out again, as you can see, n is 3, and we are multiplying it by 2, right? So if I step up again, n is 4, and we are multiplying it by 6, right? So that's this is a 6. And if I step up again, I get to this point, and in here I finally got the result. So if I step again, doesn't matter what I click, I get the final result of the program, which is 24. So yeah, that's basically how you can debug the factorial. In order to understand it, the most important thing is whenever there is a function can call itself, right, as you probably figure out, but whenever there is a function call, the computer waits until he gets the final result of that function call. So if you still don't understand it, that's okay. You maybe need to do a few recursive functions to kind of get used to the idea of a function calling itself. It's not natural for people to think about this way, alright? But yeah, that's pretty much it for this video. If you have any questions, feel free to ask, and I will see you next time. Alright, so what is a module? Well, module is basically a library that you can use. So, for example, let's say that you define a file called functions.python, and in here you have a few functions, so my function, out function, and factorial. Okay, and you would like to use this file in your other file, alright? And in the other file, for example modules.py, you would like to call, for example, the factorial functions, alright? So how do you do that? Well, you first of all import the Python file, the functions file, and you simply type in here the functions like this, simple as that, alright? And then you can invoke any function from the functions file, alright, so from this file. And how do you do that? You can simply, for example, print the result of functions dot factorial. As you can see, it already suggested me all of the functions that are in this function file. So I will use the factorial and I will pass in there 4, for example. So if I run this, as you can see, it says 24, right? So why is that? What happened in here? Well, we just called the factorial functions from this file, from this, so this function gets called with 4, right? And yeah, so that's quite useful. You can import all of the files that you already defined. You can define a library, so then it is important to have, for example, a functions that deals with, I don't know, with some part of your application in one file, and then in other file you use these functions that you defined in there. So yeah, so that it's important when you are creating some kind of a more complex application. Yeah, then you probably want to split the application into multiple files, all right? And then you can import it as a library. So another thing that you can do is rename it. So you use the s keyword, and inside here you can do, for example, a f, and then you call it just like this. So f.factorial. So if I run this again, as you can see, it just works same way as before, but this time if I type in here the functions, we will get an error. So if I run this, as you can see, the functions is not defined because we renamed the functions to f. All right, so simply type f in here and everything will work just fine. Yeah, and another thing that you can do is import the system library, so system module. So this time we imported a functions from our file that we defined, but a lot of times we want to import other functions, but from a file that somebody else created, right? So for example, some library. And in order to do that, we can simply type in here import and then the name of the module. So for example, platform, right? And then we'll import the platform module into our application, into this file, all right? And then what we can do is, for example, print the platform dot, and as you can see, there is a lot of stuff that we can do with this, right? So we can, for example, print the system, and if I run this application, it says 24, but then it says the system that I'm currently working on. It says that I'm on Windows, right? And as you can see, there are a lot of things that you can do. So that's quite simple, right? It can be useful to figure out what the user uses as a operating system. That's quite useful in some cases, and you can also figure out the version of the operating system. And yeah, there are a lot of more stuff. So if you just type the dot in here, you can go and find out whatever you want to do, right? You can figure out the Python build, for example, so what Python build it uses. So if I run this, as you can see, it says these things. And yeah, so that's how you can use a different module or module that somebody else created and use it in your application. All right, so you simply import the name of the module and then you can use it as a library. All right, and yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, and one thing that I forgot to mention is in the previous lecture is that you can import only part of file, and another thing is that you can import also a variables from the file. So let's say that in the functions.python I don't have any variables defined in here, right? But I can do so. I can define a variable called x and I can set it to, let's say, 1,000. Alright, so then I can use this variable in the modules.python, and for example like this. So if instead of the factorial of 4, I simply say x, and if I run this, it says 1,000. So I will just comment this line out, and yeah, so it says 1,000. So I can access even the variables in the file that I'm importing. Alright, another thing that you can do is import only part of the file that you are importing, right? So for example, in this functions.python, you have a free methods, right? So free functions. So this one, then this one, and then this one, right? But these two doesn't do pretty much anything, right? So we will use only the factorial function that is in here. So we want to import only this factorial functions. We don't want to import these two, alright? So how do we do that? Well, in the modules.python, we simply type this. So I will just get rid of this line and type in here this line. So from from which file we are importing. So from the functions file, we would like to import the factorial function. So factorial like this. And then we can call the factorial function. So factorial, and we can call it of 4, for example. So if I run this, as you can see, it says 24. Why is that? Well, we just imported this functions from this functions file. We imported only the factorial functions. Alright, so only this one, only this part of the code. And then we simply used it. Alright, and another thing that you may want to do is, for example, type in here x, and then you can also use the x. So print the x, the value of x variable, and if I run this, as you can see, it says 24, so that's the factorial result, and then 1000, so that's the value of x. But if I, for example, try to invoke one of the function that does nothing, so for example my function, alright, so if I try to call the my function in here, I will get an error. So if I run this, as you can see, my function is not defined. Why is that? Because we imported from the functions file only the factorial and the x, alright? And yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask, and I will see you next time. Alright, let's talk about the Python package manager. So in order to find out whether you have the package manager installed on your computer, you simply create a new file, or you can use an existing file, run it in terminal, and inside here you simply ask for the version of your Python package management. Alright, so simply type this version like this and hit enter, and as you can see, it right away pretty much tell me that I'm on the 18.1 version. You may have a newer one, but yeah, it doesn't matter. Either way, if it wrote something like that, you have the package installed. If it wrote something like pip, it's unrecognized command, you probably need to install it. So right now you can use the package manager to basically install some packages into your project. So in order to do that, you simply type in here the command install and then the name of the package. So for example, let's use a camel case. So that's quite often the package that is used to describe how the package manager works. So then hit enter, and it should install the camel case into your computer, right? So as you can see, it says downloading the file, then installing, right? And everything works, successfully installed. So then what you can do is import it into your project. So import the camel case, so camel case, and as you can see, it automatically suggested me that I probably want to include the camel case. And right now I can use every method that is defined in the camel case. So for example, I can create a new variable, and in here I can put camel case dot and then create a new object camel case like this. Cool, right? And then what I can do is, for example, print the camel case dot, and as you can see, there are a few methods. This hump is the most important one, and as you can see, we pass in there the value that we want to hump. So for example, I don't know, whatever, and if I run this, as you can see, it capitalized the first letters, right? But yeah, that's just the camel case package is not so useful, but it is great example of how you can use the package manager to install some package into your computer and then use the package and in your project, right, in your applications. So yeah, that's pretty much it. You can go to the page that I link as a resource to this lecture to figure out all the cool packages that you can use in your projects. Alright, so yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Look around. What do you see? Objects. Everything around is object. Glass of water is object. Computer is object. Smartphone is object. Even you are object. And almost every object has some attributes. For example, a glass of water can have attribute identifying how much water is in the glass. you can have attributes like gender, age, color of your hair, and your computer can also have attributes like operating system, processor, color of computer, and many more. And also, you can do stuff with objects. In computer science, it is called method. So for example, you can drink from glass of water, right? And by drinking, you are changing its attribute, identifying how much water is in the glass. And you can also fill the glass with water, right? And once again, you are changing the attributes, but you don't have to change attribute with each method. For example, if I tell you to make sound, you can make sound like and you are still male or female, right? And another important thing is that you can have more objects of the same type or class if you want. These objects are called instances of the particular class. For example, I bet my glass of water is not only one in this entire world, right? There will be other glasses, so if I drink from mine, the other glasses will not be affected, alright? And in your computer, things works pretty much the same. So you have defined types of objects, classes, and you can have more instances of the same class. Almost every object has some attributes, like its color or something like that, and almost every object have methods. And these are just things you can do with certain object, like make sound and anything like that. Almost every human can make sound, right? And methods can change the value of object's attribute, but they don't have to, alright? And that's pretty much it. If you have any questions, feel free to ask, and I'll see you next time. In object-oriented programming, computer programs are designed by making them out of objects that interact with one another. There is significant diversity of object-oriented programming languages, but the most popular ones are class-based, meaning that objects are instances of classes, which typically also determine their type. In Python and other programming languages like Java and C# and C++ and many more is used class-based system. And other system is used, for example, in JavaScript, and it is the prototype-based. But in this course, I will talk only about Python, so I will talk about class-based system, alright? Example of class is human. Other class can be computer. So in object-oriented programming, when baby is born, it is equivalent to creating new instance of human object. The structure and behavior of an object are defined by a class, which is a definition or blueprint of all objects of a specific type. So to sum things up, class is something defining attributes and methods of object. You can create more objects using one class, and these objects have attributes of this class and can perform methods from this class. Also, objects created via some class are called instance of that class, alright? And that is pretty much it. In the next lecture, I will show you how it works in the code. Alright, so how to create a class in Python? Well, it's quite easy actually. Simply type class and then the name of your class. So it can be, for example, my first class. And then com. And inside here, you type all the attributes and all the methods of your class. So for example, I can have attributes like, I don't know, x, which will be integer and it can be equal to 5. As a default value will be 5, alright? Then I can have like a name or whatever, and default value will be just empty string, alright? And yeah, so let me just create a new instance of this class. So if I want to create a new instance, I simply create a variable, I somehow call it, so for example instance1, and I will set it to new instance of the my first class. And when I want to create a object that is of this class, I simply type in here my first class and then parentheses, alright? So the name of the class and parentheses. And this will basically create a new object that have all the attributes and all the methods that this class have, alright? And yeah, I can also create other instance. So instance number 2. So this will be the same object, right? But it will be the second object. So if I then, for example, change the value of x of the instance 1, so instance 1 dot x, all right, so when I want to access some attribute, I type the dot and then the name of the attribute, all right, and as you can see, the computer automatically suggests me that I'm probably looking either for name or x, right? So I want to change, for example, the x to 10, and then let me just print out the value of x of the instance 1, and then let me just print out the value of x of the instance 2. So if I run this right now, will the instance 2 be changed? Will the second print will say 10 or it will say 5? What do you think? Well, it will say 5. Why is that? Well, we only changed the value of the instance 1 of this object, alright? And this object is completely different object, right? He doesn't care whether we changed the value of some random object, right? He only cares when we changed his value, alright? So it's the same as with the glass of water, right? If I'm drinking from my glass of water, your glass of water will not be affected, alright? Alright, so let me just right now show you what the self is and how you can create a method. So yeah, let me just get rid of this stuff and let's start creating something useful. So we will create a class called point, and this will represent a geometrical point, right? So for example, it will have the x coordinate, and let's set it to 0 from the beginning, and the y coordinate, and it will also be 0. And let's also define a method. So for example, define, and in here what it can be something like move point. So we can move point to some coordinates, all right? And what arguments we want? Well, we want the new coordinates, right? So the x and y. But we also need the object that we want to change. So the object that we want to change is in self, all right? So we always put in here self, and then we type in there the arguments, so the x and y. So I can, for example, call it the new x and the new y, so that you know what I'm talking about when I say new x and not only x, alright? Yeah, but never mind. And then let's say what we will do. Well, we will set the x coordinate of the object that we call this function on to the x, alright? And sorry, to the new x. Computer automatically fixed me, but never mind. So, and then we will set the self dot y to the new y, right? So we will basically change the coordinates of the point, all right? So yeah, right now let me just define a new class of a new instance of a point. So for example, let me say just a origin, and this will be a instance of point. And yeah, we want the origin to be at 0 and 0, right? So then we can create a new instance called, for example, I don't know, my point, and this will be equal to, once again, instance of point. So this will be, the type of this is a class point, alright? And then we can call the method over the my point. So as you can see, it accepts 3 arguments. But how do we call a method? Well, we do it a bit differently. So in here we type my point, then dot, and then we have the move point method. And inside here we type the new x and the new y. So for example, 10 and 5. So yeah, I get that this might be a bit weird, because when we talked about functions, we have like 3 arguments, right? And the first one should always be first in these parentheses, right, in the function call. Well, it is a bit different with objects. Because you call a method over some object, always, the first argument is basically this thing, alright? So this object that you are calling the method over. So this object is basically equal to the self variable, and then we are setting the x and the y property, the attribute of this myPoint instance, and we are setting it to the new x and new I, which are these two values. Alright, so if I, for example, define another method called printPoint, I can simply do that, and I will only accept the self, and then I would like to print, for example, the x is equal, yeah, whatever, and then I can turn the self into string, so the I coordinate, right? So self dot, or sorry, the x coordinate, right? So I print x is equal to the value of the x attribute of the self object, alright? And then I will, for example, print, or I can print it on the next line, maybe that will be better. So I'll print on the next line the y is equal to the y coordinate, right? So string dot self dot y, like this. And yeah, so let me just right now print the point. So my point, and then dot and print point. There should be something like that, print point, as you can see in here. So if I run this, I get an error because I forgot on the column in here. So if I run this again, I get x is equal to 10 and y is equal to 5. Alright, so basically this method changed the x and y property of the myPoint object. And if I once again run the origin, so if I, for example, try to print the origin, so print point, sorry, and I run the program, it says x is equal to 0, y is equal to 0. Why is that? Well, because we only change the values, the attributes of the myPoint, alright? So the self is extremely important, and basically the self is just a reference to the current object that we are calling the method on, alright? So we can then access the attributes of the object, right, via the self keyword. And yeah, so because in here we have the myPoint name and then we have the origin name, so it is kind of hard. How can this method know how this object is called, right? He cannot, so we just basically set it to this self, alright? And yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, in this lecture we will talk about something called constructor and what that means. Well, basically constructor is some function or some method that gets to be called each time we create a new instance of that particular class, right? So for example, each time we type in here the point, the constructor will be called. And in order to define the constructor, we can do it like this. So for example, in here, I can type define, and then I would like to create the constructor. So I type in here these two signs, alright, and then I type in here the init, and once again these two same signs, and then we take some parameters. So for example, we can take the self, the object, and then we can take the I don't know, the x coordinate and the y coordinate, right? And yeah, and then we can define what we want to do with them. So we can create a new object and we will set the x property. So for example, in here we will type in here something like a new x and new y, alright, just to be sure. And in here will be just the x, and this will be equal to new x, and then we will also set the y, and that will be equal to the new y, right? And so like this. And what that means, well, basically when we create the point in here, we specify what should be the values of the x and y. So for example, 0 and 0, right? And in here we can do, like, I don't know, also for example 5 and 2. Alright, so if I run this, as you can see, it's still in here we change the values, right? See, we change the values of the x and y properties, but in here it's a 0 and 0, and if I, for example, change it to 1 and 1, 1 and 1, and run this program, it should say 1 and 1, and it does. Alright, so in here we can basically define the default values, the initial values of the attributes of that particular object, alright, of that particular instance of this class. And yeah, so we can also set in here the default, so same way as with the previous function, and then we can, for example, get rid of all of this stuff, and when we call this it will still work, but there will be the default values 0 and 0, right? And if I, for example, change it to 2 and 2, there will be 2 and 2, so it works exactly the same way as with functions, right? And yeah, and we don't get an error when we don't pass any arguments. So yeah, this is basically the constructor and how you can define a object. And another thing that I want to show you in this lecture is how you can delete a properties of particular object. So for example, in here, let's say that I'm mad and I want to delete the X property of the origin. Alright, so I can simply type in here delete origin dot X, and this will basically delete the origin.x property. So then when I, for example, want to print the origin.x, I will get an error. So if I run this, as you can see, we get an error, point object have no attribute X. Why is that? Well, we just deleted it. But if I, for example, type in here my point, let's see what happens. And if I run this, as you can see, it just works, the X is still 10, alright? So yeah, that's how you can also delete the properties, and you can also find out the type of the object by simply typing in here the type, and then you pass the object. So for example, the origin, and let's see what type of the object is. As you can see, it says class.main.point. So main is basically this file, and point is the name of this class, alright? So it basically tells us, okay, you have there a point. So yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. In object-oriented programming languages, inheritance is when a class is based on another class using same implementation. Inheritance in most class-based object-oriented languages is a mechanism in which one object acquires all the properties and behaviors of the parent object. And very useful thing when you are setting some class as a parent class to another one is to ask yourself this simple question. It is called the is_a rule. The child class name is the parent class name. So for example, dog is a animal. It's correct, right? Because dog is a animal, right? But for example, conference room is a building. Is not correct, right? So you shouldn't inherit from building class, alright? Another example is that Ford is a car. This one is also incorrect. So you cannot inherit from car class because Ford is not a car, right? Another important rule is the KISS rule. And what that means? Well, it's keep it simple, stupid. And it is really useful. You shouldn't inherit whenever you can or whenever the is_a rule is true, right? So example of class hierarchy is here. On top we have class animal, and then there are its children, so dog, pig and cat. And there could be plenty more, right? And all of these classes inherits from animal class. So every attribute and non-private methods that animal have are also an attribute of dog, pig and cat. I think that when I show you this in the code, it will clear things up. Other important thing is method calling. Sometimes can happen that dog have method with same name as animal, and computer solves that by executing the first method that comes around, alright? So let's say that both dog and animal have method called 1 year older. If you call this method over dog object, the method inside dog class will be executed. And another important thing is, let's say that dog class doesn't have method called 1 year older, but animal class do. When I call 1 year older method over dog object, computer looks into dog class and finds out that there is no method called 1 year older. So what computer does? He tries to find this method in its parent, alright? So it goes up to animal class and finds the method 1 year older. So he executes it. And that is pretty much it. If you have any questions, feel free to ask and I'll see you next time. Alright, so in this lecture I will talk about the inheritance and we'll go through the cases, through the example from the previous lecture. Alright, so let's create a class called animal. So animal, and in here we will define the constructor for it, so init, and then we will pass the self, the name of the animal, and for example the age of the animal. Alright, and then we set basically the values of these attributes. So the name attribute of the animal will have the name value that we pass in here. Alright, you can always change the name of this so that it's, for example, I don't know, a name, whatever, right? But this will work though. Alright, and then we can set the self.age to the age property, to the age attribute that we pass. Alright, so the age property will be equal to the age attribute that we pass. Alright, cool. And yeah, so that's basically the constructor. Then we can define a function like make sound. Alright, and this one will take only the self, and yeah, it will basically, for example, print just I don't know, hello, my name is, and then the name of the animal, so self.name. And yeah, so that can be, for example, the animal class. And then we want to create, for example, I know, a dog class, and the dog class will inherit from the animal class. Alright, so we'll create a class called dog. And how do we create the inheritance? Well, simply in the parentheses behind the class, we type the class that we want to inherit from, so animal. Alright, so that means this dog class inherits from animal. Alright, and then we write the com, and for example in here we can define the constructor, so init, and then we, for example, pass the self, the name, the age, and what can dog have? A owner, for example, so owner. And yeah, then we basically define the attribute of the dog. So dog will have the owner attribute, but the name and the age will be attributes that he inherits from the animal class. Alright, so this may take some time to sink in, right? But the owner is the only attribute of the dog class. Alright, other attributes are inherit. So how do we basically, right now we would like to call the animal class, right, the constructor of the animal class, because we want to set the name and the age, right? So how do we do that? Well, we call the super, so super, and that basically allows us to access the parent of this class. Alright, so the method of the parent of this class, and in here we can type in here the init function, so init, and there we pass the self, and then we pass the, well, sorry, we don't pass the self, the self gets passed automatically, right? Because we simply type in here the super, right? So he knows that I'm calling it from this dog instance. And so we pass the name and the age, right? And as you can notice, when you type the arguments in here, it automatically underlines the argument that you are currently typing. Alright, so name and age. So this will take care of the construction of the animal object, and then we can easily set the owner attribute of the dog. So self dot owner, like this, and we will set it to the owner that we pass in here. Alright, and then we can, for example, define a function in here. So for example, something like, who is your owner? That's just too complicated, but whatever. Who is your owner will be the function. It will take the self as an argument. Alright, and so the instance of a object, and let's say it will print, for example, my owner is, and then the name of the owner, so owner, so self.owner and self.owner. And yeah, so let me just right now create the instances of the dog class. So for example, in here I will define Ben, so that will be the name of our dog, and we will create a new instance of the dog class, so dog, then parentheses. And yeah, so right now what we need to pass, well, we need to pass the name, the age, and the owner. So the name of our dog will be Ben, the age will be, for example, I know 10, so 10 years old. The owner will be, for example, Luke. Alright, and yeah, so that will create our new Ben object. Alright, so new instance of dog class. And when I, for example, want to print I know some attribute of the animal class, so for example the name of the Ben, so Ben.name, I can simply do that. And if I run this program, as you can see, it prints Ben. So we basically, from the dog object, we access the name that is defined, so the attribute of the animal class. So as you can see, it really basically takes all the attributes from the animal class and also all the methods. So right now I can for example do a ben.makeSound, which is a method, but it is from the animal class, right? So when I run this, it will basically print the hello, my name is Ben. Alright, so basically this line, even though I am calling this over a dog instance. Alright, so I create a dog instance and it will basically call a method from the inherit class. Alright, and yeah, I can obviously simply call the Ben, who is your owner, right? So who is your owner, and I can once again print it. So if I run this, as you can see, yeah, then not, I would like to write Ben, so sorry about it. And if I run this again, it says my owner is Luke, which is correct. So yeah, and another thing that I would like to show you is, for example, if I define the who is your owner method inside the animal, for example, I know why would I do that, but yeah, why not? In here I can type something like just error, and if I run this right now, as you can see, it prints my owner is Luke. Why is that? Well, we are calling this who is your owner over a dog object. So this method is the one who executes the order, right? So we will print this line. But even though the animal have also the same method, so same name, right? Who is your owner, and same attributes, right? Everything is the same, but this method is the one who gets to call, alright? So that's an important thing to note. But yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask and I'll see you next time. Alright, so let's talk about the privacy of attributes and methods. So why do we need that? Well, sometimes we would like to define an attribute of, for example, a point, but we don't want the user of this module to be able to change the attribute, right? So in order to do that, we can define a private and protected attribute, and same goes for methods, right? So for example, only we want a method and we want the method to be able to be called only from the file where the class is defined, right? So we make it private so that the user cannot call it, right? But yeah, let me just create a new protected variable. So in order to do that, you simply type one underscore and then the name. So for example, a color. So this is a protected attribute and I will just set it to, let's say, red. And yeah, so I basically, if I run the file, everything works. So if I just created a color that is assigned to every point and should not be changed by a user, alright? So if you use the point class in some other file, so if you import the point class and then you create a new point, you can, for example, then print it. So if I run this, as you can see, there's the point. But what you can also do is access the protected property. So if I print the my point, so my point dot dash color, and if I run this, as you can see, it works. So I can access the property, but can I change it? So if I do something like my point dot underscore color, and I will set it to, for example, blue, can I change it? Can I do that? As a matter of fact, I can. And why is that? Well, in pretty much every programming language, if you create a protected variable, protected attribute, the user is not able to call it from other file, right? So if you import the class and then create new object, you should not be able to change the private property. And yeah, but in Python, they took a bit different approach. They want the language to be as strong as possible so that you can do pretty much anything. But yeah, so they allow it. But that's a bit of a problem. You should never do this. If you are using a module that somebody else wrote and they make a private property, so protected property, sorry, by where this one underscore, you don't want to change the value. You may only want to access it at rare cases. But usually when somebody creates these protected properties, they also define something called getter and setter. So let me just define them in here. So getter is basically something that gets the value of the attribute, of the protected attribute. So for example, in here it could be get color, and then you pass the self, and then it will just simply return the value of the self dot dash color, right? So that's it. And the setter means basically that you want to set the protected variable. So set color, and in here you pass in the self and the new color, right? So and then you simply just set the self dot underscore color and to be equal to the new color. All right, so that's just a setter and getter. All right, and yeah, all they do is basically set the value of the protected attribute and return the value of a protected attribute. So each time you import a module that have a protected attribute, you should access it only via the getter and setter. All right. And yeah, so another thing that you can do is change it to private. So how do you define a private? You do it via two underscores. So like this, right? So there are two of them, same thing as with the init, right? And right now, if I, for example, I will change these two too. So if I change this one and this one and run the file, I get an error. All right, I forgot about right here. So if I run this again, yeah, everything works. So right now the color is private, so that means we are not able to access it. And in order to demonstrate, you simply can go to the other file where you import the class and then ask for the color. So as I'm doing right here. So if I run this program, as you can see, we get an error. So first of all, we create the point that works just fine. We print the point that also works, but in here we get an error because the object have no attribute dash color. Why is that? Well, in here the color is private. All right, so we are not able to see it in the file when we import the class. All right, and yeah, just to be absolutely clear, you are able to see it via one trick, but I won't even show you the trick because you should never use this. You should never access a private attribute or private method via the trick. All right, you should never do that. So I won't even show you the trick. And that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so let's talk about iterators. An iterator is an object that contains a countable number of values. So an iterator is an object that can be iterated upon, right? So you can go through the values. So for example, a list. So for example, if I define a new list, so my list like this, and set it to, for example, values like 1, 2, 3, 4, 5, I can iterate through this list. So for example, I can create a variable called my iterator, and I can create a iterator over this list using the iter function, and we pass in there the list, so my list. And then what we can do is, for example, print the, alright, I don't want the parentheses in here, but what we can print is, for example, the next of that iterator, so my iterator. Alright, so if I run this, you should be able to see the number from my list. Alright, so as you can see, there it is. So right, the first number, and as I iterate throughout the list, there should be 2, 3, 4, and 5. Alright, so if I run this, 1, 2, 3, 4, 5, good. But what happens if I try to iterate to the 6th number that is not in there? So if I run this, as you can see, we get the stop iteration. Alright, so that's the error. Alright, so yeah, this is basically not so useful. You can do it via a loop, right? You can iterate throughout the whole list via a loop. And yeah, another thing that you can do is, for example, change this to a string. So yeah, I didn't mean to do that, but like this, for example. So if I run this, we will iterate throughout the characters of the string. Alright, so you can do it over a list, over dictionary, over set, over tuple, and over strings, right? But yeah, that's not so much useful. But a thing that could be useful is create a class where you can define, for example, your numbers list, right? So some sequence of numbers. So for example, class, in here will be my sequence. Well, let's just make it short. And in here, we will create the method. So we will define the method called iterable. So iter, right? And this one will take only the self object. And what it will do, well, let's say that it will set the current number of the object, so self.current, to, for example, 0. And then we will, for example, each time we iterate, we will increase it by 5. So yeah, then another important thing is that the iteration method must always return the iterator. So we will just return the self, alright? And yeah, so this might be a bit weird, but you will get used to it. And another method that you need is the next, right? So next, right? As you can notice, in here we call the iterator, and in here we call the next, right? So these are the two methods that we need to define. And once again, it will take only the self as an argument. And what it will do, well, we return the value. So for example, we will return the current value of self. And then what we can do, well, we can increment it by 5. So for example, we can put the self.current, well, or we can first increment it by 5. So we will do plus equal 5, and then we will basically return it as a number. So return the self.current. Alright, so if I run this, well, if I create a new object, so for example s whatever, and it will be the object, well, it will be just an instance of the my sequence number, alright, and then we create a iterator over this. So my iter will be equal to iterator over the s object, alright, and then what we can do is print it out. So print the next of the my iter object. Alright, so if I run this, yeah, as you can see, it says 5, and if I do it again and again like this, if I run this, it says 5, 10, 15, 20. Alright, so each time we ask for the next number, we increment it by 5. We can do also by 1. That's up to you, whatever you want, right? So 1, 2, 3, 4, 5. And yeah, you may notice that this is basically how you can define the range function. If you remember from the previous lecture, far previous, when we talked about cycles, for loops, and stuff like that, we have the range function. So this is basically how you can define a range function, simple range function. And another thing that you can do is iterate only till, for example, the current is some value. So for example, you can iterate, or you can ask for the next only if the current is smaller than 10, for example. So if self.current is smaller than 10, you will return basically the next number, right? You will increment it by 1 and return it. But if it is not, you can return a exception, right? So you can raise the exception. Remember, as when we talked about the try and except, and remember when we get the error when we try to go and iterate throughout the list to a character that is not in here. Well, we will do exactly the same here. So we will define a exception. And how do you do that? You simply type in here raise and then the name of the exception. So in here it's stop iteration. All right. So that's the exception. That's all. So if I run this, it should work just fine since I'm printing only 1, 2, 3, 4. But yeah, if I change it, for example, to 3, so we will get an error. So if I run this, as you can see, 1, 2, 3 works just fine, but then we get the stop iteration error. All right. And yeah, and another thing that you can do, which is a bit more useful, is loop throughout the cycle. So for x that is in my iterator, like this, I can, for example, print the x. All right. So if I run this, as you can see, it prints only 1, 2, 3, and then it automatically stops when the stop iteration is raised, right? So if I, for example, change this to 10, it will stop at 10, all right, as you can see. So that is quite cool, right? And yeah, so that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so let's say that we have a list and we would like to figure out how many, for example, 10s are in the list. So let's write a function that does that. So simply define a function, for example, number of, and it will basically accept the list. So for example, the test list, and well, or simply just list, and then it will also accept the element. So like this, so the number of occurrences of this element in the list. All right. And how do we figure out how many times is the element in the list? Well, we will simply keep a variable, so that will be something like how many, or just occurrences. All right, so I will just simply copy paste this one, and we will set it to 0 from the beginning because we don't know how many times the element is in the list yet. But then the idea is that we will go throughout this whole list element by element, and we will compare each element to this element attribute. All right, and if they are equal, we will increment these occurrences. All right, and if they are not, we will just continue with the next one, and when we reach the end in this variable, we will have the final result. All right, so let's do that. So for each e as a element in the list, we want to do what we want to do. Well, we would like to check whether e is equal to the element, right? And if it is, we would like to increment the occurrences. All right, so we can do it like this, so plus equal 1, right? We can do it like this, so is equal to occurrences plus 1. Yeah, that's up to you. You can use plus equal, or you can use this notation. That's up to you. But if it is not, what we want to do, well, we would like to just continue, so we do nothing, right? And when we reach end, we would like to return the number of occurrences, and as I said before, we store it in this variable, right? So if I now try to run this program and, for example, print the number of occurrences of the test list, and in here the element will be, for example, 10, so there should be 3, right? 3 should be the result, and as you can see, there's 3. So let's try it out for 5. So if I run this, it says 2, and there are 2 of them. All right, so that's quite cool. And let's also try it for 1, and there should be only 1. Yeah, so yeah, that works. And let's also try it, for example, for 0, and there should be 0. All right, because there is none of the zeros in this list. So yeah, that is pretty cool. That's how you can implement the number of occurrences in the list. So if you have any questions, feel free to ask, and I'll see you next time. Alright, so let's implement the reverse string algorithm. So as you probably know, you can use the predefined algorithm, but that's not the point, and by implementing this algorithm, you should kind of learn how to create your own algorithms. Alright, so when you then come to a real problem, you should be able to solve it. Alright, so yeah, the idea is that we have a string, for example ABC, and we will change it to CBA. Alright, so how the algorithm should work? Well, as you can see, we have the ABC. So how about we go from left to right, so ABC, and we take a character, alright, so A, and then we put it at the beginning of a string that we will create, right? So we will create some local variable, and in there we will kind of keep the current result, alright? So we will always add the string to the beginning of the variable. So for example, the variable will start as an empty string, so we will add A. Then we will go through the next character, alright, so there will be B. So we take B and we add it at the beginning, as I said before. So right now there is A, so we add a B to the beginning, alright? And then we get to the last character and get to C, alright? And then we once again add it to the beginning. And once we go through all of the characters, we return this as a result. Alright, so that's quite simple idea. So let's implement that. So we will simply define a new method called reverse, and yeah, it will accept a string and we will reverse it. So how to do that? Well, in here I will define the result variable, and in the beginning it will be just an empty string, right? So this is the result variable, alright? And then, as I said before, we will go through the characters in the string. So for each character in the string, we would like to go through it and add it to the beginning of the result. So how do we do that? Well, we can basically set the result variable to be equal to the C plus the result, to whatever is in the result variable currently, alright? So yeah, that's exactly how we do that. This line might be a bit harder to figure out in the beginning, but yeah, it's not so complicated, right? You basically take the character and add it to the beginning of the result. And once you go through all of the characters in here, you can simply return the result. So return the result, and yeah, that should work. So if I, for example, try to print the result of reverse, and then I pass in there, for example, A, B, C, D, whatever. So if I run this, as you can see, it says DCBA. So yeah, it reverse the string. So for example, if I pass in there hello and run the code, it says OLLEH. So I guess that's right. Yeah, so yeah, that's basically how we can define the reverse string method all by yourself. And yeah, if you have any questions, feel free to ask, and I'll see you next time. Alright, so the next algorithm that we will implement is called the sum of list. I'm not sure whether that's the proper name, I just called it this way. But yeah, it basically takes the list and returns the sum of all the elements in the list, alright? So how do we do that? How do we create such an algorithm? Well, the idea is that we will have a variable. In there we will keep the result, and we will go through all of the elements, and we will basically add the elements to the result variable, alright? So let's do that. In here we will define, for example, a sum of list, and it will take the list, right? And for the list, what we will do, well, we will create the result variable, and from the beginning we will set it to 0, alright? And then we will go for every element, so element in the list number, in the list, and what we want to do is basically add the element to the result. So result will be plus equal the element. So yeah, that's pretty much it. And then we can simply return the result. So as you can see, it's quite simple. And if I, for example, try it out, so if I print the result of sum of lists and I pass in there some lists, so for example 1, 5 and 5 and 2, so that should be 13, and in here, that's it. And if I run this, it says 13, right? Cool, so that works. And yeah, so as you can see, there is a bit of a pattern with this problem. We always go through each of the elements. We sometimes have some variable in where we keep the result, right? So pretty much these two algorithms are not so different. And yeah, so if you have any questions, feel free to ask, and I'll see you next time. Alright, so in this lecture we will solve the biggest number in list problem. So the task is quite simple. You simply get a list and you want to return the biggest number from it. So how do we do that? Well, I will simply define this method, this will be, or function, this will be just, I don't know, biggest, and it will accept the list. And for the list, what we want to do? Well, first of all, we would like to define the biggest yet, right? So the biggest, well, just the biggest number, all right? And this will be what it will be. Well, we need to set it to the first number from list, right? So list on index 0, all right? And then we will go, for example, while I, all right? So I will be 1. So we will start at index 1. And we will compare it to all the elements behind. And if we find element that is greater than whatever is stored in our biggest, we simply changed it. Alright, so we will change the value of the biggest, and yeah, then continue once again with elements behind. And when we reach the end, we have the biggest number in the biggest variable. So inside here, we will simply type the while cycle, and we will cycle while I is smaller than the length of the list, so like this. And yeah, and then we will basically, as I said, we will check whether the element on index I, alright, so for example right now it will be on index 1, is greater than whatever is stored in the biggest variable, alright, so whether the, or in other words, whether the biggest is smaller than the list on index I. And if it is, we want to set the biggest to the list, to the number behind it, right? So to the list on index I. Why? Because the list on index I is greater than the biggest set, and yeah, and we need the biggest number, right? So it should make sense. And then after this condition, we need to increment I, so I plus equal 1. And yeah, after this while cycle, we can simply return the biggest, because that's the biggest number. So let me just try this out. So inside here I will just print, so print the, oh my god, print, and inside here we will print the result of biggest of, I don't know, let's say 1, 5, 8, 10, 1, 2, whatever, and last number will be 6. So this should be like 10, right? So if I run this, as you can see, there is 10. And yeah, so it would work for all the numbers. If I change this one to 11, it will print 11. Alright, it works. So yeah, that's pretty much it for this lecture. Alright, in this lecture we will talk about the number of words in string problem. So the idea is that we get a string and we need to compute how many words are in the string. So in other words, we need to compute how many spaces are there, alright? So, but as you can see, there are 4 spaces, right? So 1, 2, 3, and 4, but there is 5 words, all right? So yeah, so let's define the function. So define the, for example, number of words, and it will accept some strings. So for example, just a input, we'll call it input. And what we need to do? Well, inside here we will define a variable called count, and we will set it by default to 1, alright? And then the idea is that we will simply count the spaces in our string, alright? So how do we do that? Well, we can just loop throughout the whole string, and if a character is equal to just a space, we simply add it, right? We can simply just add 1 to the count, and then we will have in the count variable, we will have the number of words. So yeah, so for every character in the input, what we want to do? Well, we want to go through it and check whether the character is equal to space, alright? If it is, we can basically increment the count. So count will be plus equal 1. Oh, sorry, plus equal 1. And if it is not, we can simply move on, right? Because we are going through some word. And then at the end, we are done and we can simply return the count. So like this. And if I, for example, right now print this, so try it out. So print number of words, and inside here I will pass something like, well, maybe I will just pass this string to save some time. And yeah, so if I run this, as you can see, it prints 5, so that's quite cool. And if I delete, for example, one word, it will print 4. So yeah, that's cool. But the problem is that if I pass, for example, just an empty string, it will print 1. But empty string doesn't have any words, right? So that's just wrong. So what we need to do? Well, first of all, we need to check. So I'll just check if the, well, first of all, if the length of input is equal to 0, we want to just return 0, right? Because there is no character. So if the length of the input, so like this, is equal to 0, so I can do it just like this, equals 0, I want to return 0. So I just want to return 0, like this. And yeah, and another thing that can happen is that somehow the string, for example, ends with a space. So like this, alright? So even though there are actually like 2 words, so these 2, like the computer returns 3, alright? So we also need to check whether the string ends with the space. So we will do that down here after this cycle, alright? We will just basically ask if the input on index of length of the input, so the last element minus 1, so this will basically takes us to the last element, alright? So this is the index of the last character, alright? Because the length of the input points right behind the string, so minus 1 basically takes us to the last character, and we check whether it is a space. And if it is, we can simply decrement the count. So count will be minus equal 1. Alright, and yeah, so if I run this right now, it should print 2, and it does, alright? And yeah, so, but if I, for example, get rid of the space, it still says 2, so that's correct. And yeah, so that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, in this lecture we will take a look at the isPrefix problem. So basically we will define a function that takes 2 strings. First one is just a string, and second one is the prefix, alright? And we will check whether this string is at the beginning of the first one, alright? So as you can see, in this case this is true, and in this case it is false because it starts with AB, not BC, alright? So let's define the function. So define the isPrefix, and it will take just 2 strings. So for example, just an input and then prefix. And what we want to do? Well, first of all, we would like to check whether the length of the prefix is smaller than the input, right? So in other words, we can check whether the length of the input is smaller than the prefix, right? So if the length of the input is smaller than the prefix cannot be the start of the length, right? Sorry, of the input, right? That doesn't make sense. So the length of a prefix. So then we just know that we can just return false, because that's just false. The prefix cannot be at the start of a input if it is longer, right? That just doesn't make sense. And yeah, but if it is equal or smaller, we can simply loop through the prefix and check whether the element on index I of the prefix is equal to the element on index I from the input. So yeah, in order to do that, we will define I and we will start at 0, and then we will go while I is smaller than the range. Well, yeah, we can do it just via a for loop or a while loop, but it pretty much doesn't matter. You can do it via for loop with the range function, but if you do it via while loop, we can simply do it while I is smaller than the length of the prefix, right? Because that's all we care about, right? The other characters in the input are just, we don't care how they look like. So then what we want to do is check whether the element, whether the character in the prefix on index I is equal to the element in the input on index I, right? If it is, we just continue with the next character. But if it is not, we need to return false. So how do we do not equal? Well, we simply change this to this. So the exclamation mark means not equal. So if it is not equal, we return false, right? So we return false because there is no point in comparing all the other characters because it is already know a prefix, right? So yeah, cool. Then what do we need to do? Well, we need to increment I. So I will be plus equal 1. And when we increment I, we basically move in these arrays of characters. And yeah, when we reach the end and we didn't return true, that means all of the characters are equal, right? So A is equal to A, B is equal to B, and we reach the end, so we return true, all right? So inside here, we can simply type return true. And yeah, so let's test this. So print, and inside here I will just pass these two, and this should print true, and then I will pass these two, and that should print false. So inside here I will once again do print, and let's try this out. And yeah, all right, I forgot on the function call. So it's prefix obviously, and then we pass these two. All right, so that's a bit embarrassing, but whatever. I will not cut it out, I promise. And yeah, inside here we'll also do the is prefix, and if I run this again, it works, right? So the first one returns true and the second one returns false, all right? And yeah, so that's about it. If you have any questions, feel free to ask, and I'll see you next time. Alright, so in this lecture we will implement the algorithm that is solving the problem of finding out whether a list is sorted. So for example, this first one is not sorted because 9 is obviously smaller than 11, for example, but this one is sorted. So it goes from the smallest to the biggest element, right? And yeah, so let's define the function that will check that. So is sorted, and it will accept the list, right? And then what we want to do? Well, how do we know that array is sorted? Well, if we take a look at every two numbers or two elements from the list, if the left one is always smaller than the right one, smaller or equal to the right one, the array is sorted, right? But if at least once the left one, so that means for example 11 is greater, than the right one, so for example 9, the array is not sorted, right? So basically we will check for this. So we will check whether the left one is always smaller or equal to the right one, and if it is not, we will return false. So we will go through the array. So I will just define a new index call, and I will assign it to 0, and we will loop while I is smaller than the length of the list, right? And what we want to do? Well, we would like to check whether the element on index I is smaller or equal to the element on index I plus 1. Or in other words, we would like to check whether the element on index I is greater than the element on index I plus 1, because if it is, we know that the array is not sorted and we can just return false. So yeah, let's do that. So if the list on index I is actually greater than the list on index I plus 1, so the element behind, we return false, right? So return like this, false. Yeah, and other words that I may forgot to mention is that you have to type the F capitalized, alright? So if you type in here false like this, you will get an error, alright? You need to type false. And yeah, so if, back to my point, if the left one is greater than the right one, we return false, right? But if they are not, we can simply move on, right? So we will simply just increment I, so I plus equal 1, and move on to the next number. So then when we reach the end, we can simply return true, because we know that this condition is true, is false for all the numbers, alright? And yeah, another thing that you may want to notice is that, will this work? In my opinion, it will not. But why? So you may want to pause the video and try to think about it, why this will not work. But yeah, I'm about to tell you, so pause it right now. And yeah, so the problem is in the length of the list. So we are checking whether I is smaller than the length of the list, but then we reach for the I plus 1. So what happens? Well, for example, the length of this list is 3, right? So what happens when I is equal to 2? Well, we are pointing at the 9, right? So I is equal to 2. This while condition is true, so we continue with these lines. So I is 2, so we check for whether the 9 is smaller than the I plus 1, so 3. And there is no element on index 3 in here, right? So we will get an error. So what we need to do? Well, we need to check to the second to last number, so to 11, alright? And we need to skip the last, because there is no other numbers to compare it to, alright? So we will simply do that by writing in here -1. And yeah, so if I run this algorithm, so for example, if I print whether it's sorted in this array, so this list, so if I put it right here, and yeah, and I'll also print other list that is actually sorted, so yeah, that can be like 12 inside here. And yeah, if I run this, as you can see, it prints, yeah, it prints also these stuff. So I'll just comment it out and run this again, and it prints false and true. And that's correct. So yeah, if you have any questions, feel free to ask, and I'll see you next time. Alright, so far we have created applications, right? But those were just console applications, so basically just text application. But all the application you probably know are some like graphical application, right? Like some window and some buttons inside the window, right? So was that all useless? Well, not at all. So all the things that we talked about was the functionality behind those applications, as you can see, for example, right here. And the other part of the application is the graphical user interface, so GUI, and this basically stands for the buttons and the things that you see, right, for the window. So basically everything, every layout in a window is a graphical user interface of some program, and all the if conditions, cycles and stuff like that, they are on the background, right? They are taking care of the functionality. So right now, let me show you how you can define a new window. Alright, so we will start creating a window application. So let's get into it. First of all, what we will use is a class, or basically a library called tkinter. Alright, so that's probably the most used library for Python graphical user interface. And yes, so in order to start with that, simply in here type import and then type tkinter. Like this, alright? It automatically suggests you tkinter. And then what you want to do is, for example, create a new window. All right. So how do we create a new window? Well, for example, inside here, I will simply define a window variable, and this one will be tkinter dot, and then should be tk. All right, so tk, and that's basically a class that stands for the new window. All right, so right now we constructed a new window instance. All right, and now what we want to do is loop through the window till the application is closed by user. All right, so how do we do that? Well, we simply type in here window dot main loop. All right, so main loop, sorry, like this, and parentheses. So if I run this, window instead of windows. So if I run this, as you can see, it shows a window. So if I simply move it inside here, as you can see, there is the window that we just created. So let me just talk you through the process. Well, inside here, we tell the computer that we want to create a new window. So we create a new instance of a window. And then this line basically takes care of the window being shown. Because when we create a new instance of window, it basically disappears right away. All right, so this line basically takes care of the problem that the window is still being shown. All right, so that we can actually see it. And yes, so right now let's do the fun part. So inside here, we basically take care of the creation of the window, and inside here, we basically show the window. So where should we put our elements when we want to add, for example, something like buttons and stuff like that into our application? Where should we put them? Well, exactly in between those two, so on the line 4. So for example, let me just say that I want to create a new element, and this one should be label. All right, so labels are pretty simple. So we simply create a new variable called, for example, label hello, and we will create a new instance of the tkinter dot label. All right, and then in parentheses we simply pass the master. So what is the master? Well, master basically stands for the element in which we want the label to be displayed. All right, so where we want the label to be displayed? Well, we want it to be displayed in the window, right? So we simply pass in here the window instead of windows. And yeah, then what we can do is define all the properties. So for example, the text, which is the most important property of a label, and we can set it to, for example, hello world, like this. And yeah, so right now we have created a new element. All right, so we created a new label that will be shown in the window that we just created on this line. And then what we need to do is actually show the label, because right now we just created it. All right, we prepared everything, but we still didn't show it actually. So how do you show the label? Well, it's quite simple. You simply type in here label hello, so the name of the variable, and then dot, and then pack, so like this, and parentheses. All right, you can also define the position in the pack, but we will take care of that later on. All right, so if I run this, you should be able to see a really small application, and as you can see, it says hello world inside. So that's quite cool, right? We created our first application that have a window. And yeah, so that's pretty much it for this lecture. If you have any questions, feel free to ask, and I will see you next time. Alright, so in the previous lecture we talked about the labels, right, and how you can show a window. But what we want to do now is basically tell the computer where we want to show the elements. So let me just get right into it. So we can import the tkinter once again, but since we always, if we do it like this, so if we type import tkinter, we always need to type in here tkinter dot something, right, label or something like that, and that's kind of pain in the ass. What we want to do is simply type in here label, right, or so something like this. And how do we do that? Well, we can simply type in here this from tkinter. We would like to import everything. which means this star, alright? So this star basically stands for everything. And right now, when we want to create a new window, so for example, window, window, and we can set it only to the TK, alright? So TK and parentheses, alright? So we don't have to write the TK enter right now. Cool. So right now, let me talk you through the things that we need to do. And first of all, we need the window to be shown. So window dot main loop like this, parentheses, and then we will define few elements. So each time we want to style something, so that means basically divide the windows into some parts. So as you can see on this editor, as you can see down here, there's one part for the console, and in here is other part for the files, right? And in here is other part for the text editor and stuff like that. So the application is divided into parts, right? Into like invisible rectangles, basically. And these invisible rectangles are called frames. So frame is basically a part of the application, so part of the window, where you can place other elements, but there is not actually any element, so you cannot see anything, right? You don't see the frame, it's invisible, alright? It's only for the programming purposes. So for example, let me define two frames. So first one will be frame, so f the top, so f top, that will be a frame on top, and then we will have a frame on bottom, alright? So the frame on top will be simply created by typing here frame, and then in parentheses we want to pass the master, so that will be the window, right? And yeah, so that's basically it. And the other part that we have to do when we create an element, we need to show it, alright? So we need to do the frame on top dot back, alright? So that basically stands, alright, I want to show the frame on top, alright? And then we will create the bottom frame, so frame bottom, and this will be also a frame, and inside here we will once again pass the window, and yeah, then we simply type in here the frame on bottom would like to be also packed, so we also want to show it, but this time we will define where we want to show it, alright? So inside here we type something called side, and then we type in there the side where we want to show it. So we have like left, top, right, and bottom. So we type in the bottom like this. And yeah, so that will basically show the bottom frame on the bottom of the application. Alright, and then what we can do is, for example, define a few labels. So label 1, alright, whatever, and it will simply be a new label, and it will once again be right now there's a difference. Instead of the previous lecture, in the previous lecture we displayed the label directly inside the window, right? But right now I will show you the functionality of these frames, because right now we are not showing the label inside a window, but we are showing it inside a frame, right? So for example, in the top frame, so f top, alright, and yeah, then we can define the text. So the text can be something like I don't know, something like hello, whatever, it can be anything. And yeah, so then let me define other label, so that will be just label 2, and then we will have once again label 3, and this label will be on the bottom, alright? So on the bottom of our application, sorry, the f bottom like this, and it will say, for example, bottom, and this one will say top, alright? So then all we need to do is basically display these, alright? So same thing as before, we simply type in here label 1 dot back, alright, and same goes for the label 2 and label 3. So I'll just copy paste it to save some time and type in here label 2 and label 3. So if I run this application, we get an error because the text should be in lowercase, so like this. And if I run this again, it works. And as you can see, if you make the application a bit bigger, right? The bottom is on the bottom and the hello and top is on the top, right? So we basically have the two invisible rectangles. So first one is up here and the second one is down here, all right? And inside those rectangles, we are placing the labels, all right? And yeah, so right now you may wonder why they are underneath, right? Why these two labels are not next to each other. So yeah, well, that's just the default setting. You can obviously change it. And how do you change it? Well, it's quite simple. So simply go back to your editor, and when we are displaying the items, what we want to do? Well, we would like to display them but left, right? On the left side and, for example, on the right side. So let me just show you how that works. So inside here, we type side, and let's type in here left, and then inside here, let's type also side, and let's try right so that you can see how that actually looks. So if I run this, as you can see, those labels are basically next to each other, right? So the label 1 that says hello is on left, and the label 2 that says top is on right, alright? So yeah, that's quite cool, right? Alright, so in this lecture we will talk about probably the most important component, which is a button. In every application you have buttons in some sort, right, in some way. So it is important to know how to create them. So in order to create a new button, I will simply create a new variable called button, and I will assign it the value of a button, so new instance of a button. And inside here, what I will pass? Well, for now, I will only pass the window, otherwise you would probably want to pass the frame, right? But for this teaching purposes, I will pass the window as a master, so inside the window I will show the button, and then I can define all of the cool parameters. So let me just quickly talk you through them. So first one is a border. Alright, so the border of the button, so it's by default, it's 2. So if for example, I'm mad and I will change it to 20, the border will be extremely big. Alright, so that's like, that will be huge. And yeah, so then what we can define is, for example, a background color. So simply type BG, and you can assign to it a value of string and, for example, green in it, alright? So it will have a green background, then comma, and each time you are defining a new parameter of the button, you simply type comma, alright? And yeah, so then what we can define? Well, we can define the foreground, so basically the color of the text. So foreground, and we can assign to it, I don't know, white, alright? So then, probably the most important thing, which is the text of the button, so what text it will show. And for example, for now it can say click me. Alright, and yeah, so it's getting quite big, so I will just hit enter. Well, I will first of all write comma, and then I will hit enter, and we will start writing the other parameters on the next line. So that will work just fine, alright? And yeah, so other thing that you may want to define is a padding. So basically padding of x, so on the x coordinate, alright, and then padding on the y coordinate, so that means up and down. And yeah, so it's basically a number, so I will assign to it, for example, 50, and the padding y will be, I don't know, maybe a bit greater, so that you can see the difference, right? The button will look terrible, I can assure you of that, but yeah, it will just, you will see what these lines does, what these parameters does to the actual button, alright? So yeah, let me just show the button. And yeah, another thing that I want to touch on is that for now we use the peg to display the button, to display any element, right? So what we can also do, the peg will work just fine, but what we can also do is the place. So the place, and inside here we can define the x and the y coordinates. So x can be, for example, 50, and y can be, for example, also 50. Alright? So we will simply define these, we can basically define where we want to place the element. So if I run this, as you can see, it displays a new window, which doesn't look quite good, so I will just make it a bit bigger. Alright, and as you can see, the button looks actually horrible. It's like, that's so ugly, but never mind, right? So as you can see, the border is extremely huge, right? So the border of the button is extremely huge. So that's this 20, so 20 pixels. That's like quite big number. And then we have the background, so as you can see, it's green, and the foreground, so as you can see, the text, which is white. All right, then the text which says click me. All right, so you define the click, sorry, not the click, the text of the button, and then you basically define the padding on x coordinates, so that means from left and from right, both sides at the same time. All right, and yeah, so that's 50, and the padding on y is 80, right? So as you can see, the button is more, the height of the button is greater than the width of the button, so that makes, yeah, it looks terrible, right? But that's not the point. I just want to show you all kinds of cool things that you can do with the button. Alright, so yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so far, if I run the application, we got a working button, right? So that we can style a bit. Well, and when I say working, as you can see, when I click on that, nothing happens, right? Only it looks weird, but nothing much happens. And yeah, so we want to add the functionality, we want to do something when user clicks on the button. So how do we define what we want to do? Well, we will define it via a event. So what event means? Well, basically, when some event happens, which event is basically that user, for example, clicks on a button, we want to define a function that will be called, alright? So yeah, let's do that. Simply inside here, when we want to do that, we type in here the command, so command like this, and then we type the name of the function that will handle it. So for example, handle click, alright, so like this. And let's define the function. So define a function called handle click, like this, and it will accept no arguments, and I will just simply print a, I don't know, button clicked. Alright, so we should be able to see it down here in the terminal. So if I run this application right now, the application is shown, and if I click on that, as you can see, it tells me button click, and each time I click, it prints out the button click again. So as you can see, that's quite cool. Right now you cannot see it, so if I make it a bit bigger, as you can see, there are a lot of clicks. So yeah, you can obviously go crazy with that, but that's pretty much the main point of this lecture. So if you want to define what to do when, for example, user clicks on that, on the button that you created, simply in the command, when you're creating the button, type the name of the function that will be called when the button is clicked. Alright, and then the button is called, as you can see on these examples. So yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so how do we deal with inputs? In pretty much every application you have a input of some sort, right? So some basically field in which you can write some whatever, some text or something. And yeah, so how do we create that? Well, in order to create it, the creation part is quite simple. So in here we can, for example, type the entry, so E as a entry, and we will create a new instance of a entry object, and we will display it in our window, alright? And then we can define all kinds of cool parameters. Most of them are quite similar to the parameters from before. So we can define, for example, the foreground, so FG, and inside here we can, for example, type green. I don't know why I'm typing green always. You can use other colors, obviously. And yeah, so then we can, for example, define the border, right? You can define all kinds of stuff. So I'll just make it, for example, 5. And for example, let's change also the background. All right, so background, and that will be a black. All right, so black. And yeah, so let me just display this thing. So simply e.pack, and yeah, so if I run the application, you should be able to see a black input that takes a green text. And there you have it. So black input, and inside here as I'm typing, it's green text. Alright, so it's basically like a matrix or something like that. Yeah, so it's exactly not like matrix, but whatever. And yeah, then we can accept the variable. So what we want to do now is basically take the text that the user writes, alright, and put it into a variable. So how do we do that? Well, first of all, we need to define a new variable called, for example, input. So that would be what user wrote, or yeah, it can be a different, for example, user wrote, alright, and yeah, and we will assign it to a new instance of the string variable object, alright, so like this. So this is basically an object that is designed so that it can take as a input the entry that user wrote, alright, so the stuff that user wrote into the entry object, into the instance. And yeah, so right now it's not quite simple. First of all, we need to define the variable, right? So right now we need to bind this user wrote variable to the entry object. So how do we do that? Well, simply inside here, we write the most used parameter, which is the text variable. So text variable like this, and we will assign it to the user wrote. So user wrote like this. And yeah, so that basically it connects the entry and the user wrote variable, alright? But now we still get a problem, because even though each time that user types a character, it is binded into the user wrote variable, so the user wrote variable will be changed. We still don't have any information when the user actually types something, alright? So we don't have any like command or something like that that will event us when the user starts writing, alright? So that's quite bad. So what do we do? Well, we can define a trace. So what is a trace? Well, trace basically means that we wait for some event. So for example, we wait when the variable user wrote is changed, and when it is changed, we call some function, alright? So yeah, let's do that. So in order to define the trace, you simply type in here the user wrote, and then dot trace, and inside there you first of all type the mode, so that will be w as a wrote, and then we will define the callback. And the callback is a lambda expression, alright? So we type in here the lambda, and it accepts three values, alright? So the first one is a name, so the name, then it accepts the index, and then it accepts the mode, alright? And for these three, we can do whatever we want. So we can, for example, print, well, yeah, we want to call the callback. So for example, print value, alright? So that will be our function that we want to call. And yeah, so let's define it. So define the print value function that accepts no arguments, and we will, for example, just print the value of the user wrote variable, alright? So inside here I will simply copy paste it and then type dot get. So why can't I just print the user wrote variable? Well, that is because this is a object. This is a instance of a object, and inside the instance is a variable, well, is a attribute in where we have the actual text that the user wrote. So we need this get method call to give us the actual text, alright? But yeah, so right now if I run the application, and if everything should work, so if I move it inside here and start typing, inside down here should be some text. So if I type, as you can see, it prints the text as I'm writing it, right? So that's quite cool. And as you can see, each time I write a character, right, the text changes. So this trace, so what is basically happening? Well, when I write a character, the trace somehow notices that I wrote something, alright, and it calls this lambda expression. And this lambda expression calls this print value, alright, so this print value gets to be called, and this print value basically prints the current thing that we have in the window, right, in the user rogue variable. So will it work if I, for example, start deleting stuff? Well, it would, alright, so as you can see, it deletes as I'm deleting, as I'm clicking. And yeah, so basically that's it. The trace might not be so clear to you for now. It's a bit complicated topic for now. So it basically, the trace allows you to define a event when something occurs. So you define a callback, so basically something like function that gets to call when something happens. And you can define it over a object, which is a instance of the string var, alright? And yeah, so, and then you also need to connect the object with the actual entry, alright? So as you can see in here. And then everything works. So getting the input is a bit complicated. I would do it differently if I were programming Python, but I'm not, so yeah, that's pretty much it for this video. If you have any questions, feel free to ask, and I'll see you next time. Alright guys, so welcome to this lecture. In this lecture we will talk about the grid. So what is grid? Well, you can think of a grid as a imaginary table inside your window, alright? So inside your window you have something like imaginary table that have rows and that have columns, alright? And yeah, and you can place elements inside these, alright? So you can use these to basically define where you want to put your elements, alright? So let's say that I first of all need to create few elements. So let's say that we'll create some, I don't know, basic like login form, alright? So, well, we need like two labels, for example. So label, I don't know, it can be label user, for example, like this, and we will accept, well, first of all we will say that we want to accept the username, alright? So we will create a new label, and inside here we will set the master to window like this, and then we will pass in there the text parameter, and that should be something like username, alright? So username. And yeah, and let's also create second label, which will be similar, only this time it will be for the password, alright? So password, and yeah, inside here I will simply type password. And alright, and then what we need to do, well, we need the entries, alright, for the form. So this form will not work, so I won't specify any variables for the entries to bind the value that the user actually wrote. This is just for the teaching purposes of the grid, alright? So I'll just create the elements. So this one will be, for example, E1 as a entry 1, and we will basically just create a new entry, and we'll keep everything default and just place it in the window. And then I will create a second entry, so I can maybe make it like entry password and entry user, so like this, alright? And yeah, I will, the second entry will be just a new entry that will be placed somewhere in the window, alright? So yeah, these are just our elements, and right now what we want to do is actually place them somewhere. So how do we do that? Well, we simply type in here the label user, for example, and we want the username to be in the row 0, alright, and then we want the password to be in the row 1, alright, so underneath. So how do we do that? Well, simply inside here we type grid, and then we pass as a parameters the row. So row will be equal to 0, alright, so this is the row on the top, and yeah, and then we will also show the password, so like this, and inside here will be only the password, and we will change the row to 1 because we want the password to be underneath, right? We want the label for password to be underneath. And yeah, and then what we want to do is also display the grids, the entries. So how do we do that? Well, we do pretty much the same. So the entry for the user will do just grid, and then we will place it once again in the row 0. All right. So the entry for the user will be just next to the label. All right. And then we will do the same thing for the password. So entry password. And let me just run this, and I'll also change this one to 1. And let me just run this and see what this looks like. As you can see, it doesn't look quite good. Why is that? Well, first of all, the labels are not in here, right? As you can see, there are only the inputs, all right? And the labels are underneath, all right? So what do we also need to define? Well, as I said before, there are rows and columns, all right? So by default, the columns is 0. So that means the most left one, all right? But you can also set it column to 1, so that means the next to the column next to it, that's right. So you can think of it as a table. You have a imaginary table inside here, and you can place it just into some cell, all right? So yeah, let me just inside here move these entries to the column 1, all right? And both of them will be in the column 1, right? Because we want both of them to be placed to the right. So if I run this again, as you can see, it looks a bit better, right? So as you can see, we have the username, then we have the password, and inside here we can type some stuff. And yeah, so cool thing that you can also do is, for example, align these to either left or right. So inside the cell, currently it is aligned to center. So I'm not sure whether you can see it. So if I, for example, change this to only this thing and run this again, as you can see, these labels are placed in the center, but usually they are placed to the right, all right? They are aligned to right. So how do we change that? Well, inside here, inside the grid, we can simply define it. But how? Well, we use the sticky parameter, and inside here we define the side where we want to align it. So we have, but this one is different. Inside here we type the north, south, east, and west, all right? So north means basically up, south down, east is to the right, and west to the left, right? But so yeah, that's a bit weird, because you usually want to write top, left, bottom, right? But yeah, inside here you simply type the sticky, all right? Sticky, and then the north, east, south, or west, all right? So it can be either N, right, or stuff like that. So I'll just keep it to east, and if I run this, as you can see, the form looks much better, right? They are aligned to the right, all right, to the east. And yeah, so that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so pretty much every application have a menu in some sort, right? So on the top, as you probably can't see it because I'm on full screen, but on the top is usually something like file, edit, and yeah, so some menu. And each time you, for example, click on file, there's a drop down menu, so there are several, there is like sub menu, alright? And yeah, so pretty much every application have that. So it is important to know how to create that, and I will show you how to do that in this lecture. So first of all, I will import the tkinter. So from tkinter import everything, then I will create a new window. So that will be just a new instance of tk, and I will also create the main loop. So main loop, and yeah, and inside here I will create the menu. So each time you want to create a menu, you simply type in here the, for example, main menu, and then you assign to it a new instance of menu. And as you can see, you have to pass the master, so that will be just the window. Alright, And then what we need to do is basically tell the window that we have a menu and we want to show it inside this window. Alright, so how do we do that? Well, it's quite simple actually. Inside this, we simply type window dot config. So configure basically. And then what we want to config? Well, we would like to change the menu and we would like to set it to this variable. Alright, so to the main menu. So main menu. Sorry, like this. And yeah, so that will basically take care of the connecting this menu to this window. Alright, so we will have a window and on top will be this menu. Alright, so then what we want to do is add some stuff to the menu, right? So for example, how to do that? Well, it's quite simple. So main menu dot, and if you type in here add, as you can see, there are a lot of things that you can do, right? There's a lot of things. So for now, we would like to create a new cascade menu. So each time you click on file, we will create basically the copy of the file. So each time you click on file, there is a new drop down menu that appears, and yeah, so we will do that. So in order to do that, is simply type in here add cascade. So this will basically add a new menu. And yeah, so first of all, you define the label. So that means what do you want to say, and we want to say the file. And then you also define what do you want to show. So basically the submenu. All right. And yeah, and what is that? Well, that is just a instance of this menu. So we need to create a new menu for the drop down. So for the submenu that is shown when you click on the file. So we will just create, for example, file menu, and we will assign it to a menu, and the master will be the main menu. All right. So the master will not be the window, but the main menu, because we want to show it like this should be a child of the main menu, right? It makes sense, hopefully. And yeah, then we want to assign it as a menu to this main menu. So basically right now we added a item to the main menu that will say file, and when you click on that, the file menu will be shown. So right now what we want to do is basically define the file menu. So how do we do that? Well, it's quite simple. So inside here we can type the file menu dot and then add, but we will not add any other file menu. We will simply add the command. All right. And what do you have in the file menu? Well, you have the open, save, and close, right? So open, and yeah, and then inside here you can define a function, but yeah, for now we will just keep it simple. Maybe we will add it later. So then we want to add the save and close. All right, so save and close. Sorry, and close. And what that does? Well, basically it adds the item into the file menu. All right, and yes, so let me just run this thing and see how that looks. It should already look quite good. So as you can see, there is the file, so the top menu, and when I click on that, as you can see, there's the open, save, and close. So yeah, sometimes in a program you may notice that there is a separator, so basically a line between, for example, these two, between the save and the close, to basically, I don't know, add related stuff together. All right, so yeah, let's create the line. So in order to do that, you simply type in here the file menu and then add the separator. So yeah, as simple as that. It's just a line, right? How hard can that be? So you simply create a new line that will separate the open and save and the close. All right, so if I run the program right now, it's quite usual, this separator. You would have a problem finding an app without the separator actually. So you may not even notice that, but it's almost in pretty much every app. So as you can see, there is the line between the save and the close to basically, I don't know, separate these different items. So cool. Now, what we want to do? Well, we would like to add a functionality, because right now when we click on any of these menu, it does nothing. So remember how we added functionality to the button? Well, it's exactly the same. So simply in here type the command, so command, and then you type the name of a function. So for example, the test function, and I will also define it. So define the test function, and it will accept no arguments, and it will just print some ages, whatever. And yeah, I'll just copy paste it into all of the others. So obviously these functions would be different, right? This function would, for example, close the window, and this function would, I don't know, save the file if you have some file in that, but just for the teaching purposes, I will keep it simple and just print some ages. And yeah, so if I click on that, as you can see, there is the HHH, and yeah, so that's quite cool, right? So let me also show you how you can add another command. So for example, in the main menu, you usually have something called edit, right? So let me just add it. So main menu, and then we can add another cascade, right? And the label will be, for example, edit, and the menu will be edit menu. All right, so edit menu. And right now the edit menu is not defined, so we need to create it, and we need to create it above this because we are using it right now. So inside here I will just create the edit menu, and I will once again assign it to the new instance of a menu, and the master will be the main menu, right? Because the edit menu is a child of a main menu. It makes sense, hopefully. And yeah, so then what we can do is basically add some stuff to the edit menu. So what is an edit menu? We can add commands, something like, I don't know, there is like a undo, right? So undo, undo like this. Oh my god, I can't type. Undo, and then I can add something like redo, and yeah, and obviously you want to add much more stuff, all right? But yeah, for the teaching purposes, this is enough. And let me also add to the main menu just a simple button. So yeah, sometimes in the menu you don't want a drop down, you want only, for example, just, I don't know, something like help button that there's no drop down. It will basically just open, for example, a new window, or I don't know, something like that. So simply type in here main menu and then add command, and inside here we will put the label to be equal to help, for example. So if I run this, I get an error, so somewhere I get a typo. All right, inside here should be menu, and if I run this again, the file looks quite good. So file, everything works just fine. Then the edit, okay, as you can see, undo, redo, it does nothing because we didn't assign any command to it, right? So but the command would work also. And there's the help, so there's no drop down, it's just like basic item in a menu, all right? And obviously we can also assign a command to it, same way as before. So yeah, that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Well, hello guys, and welcome to this lecture. In this lecture we will talk about the canvas, so let's get into it. So canvas basically means like a drawing board where you can draw a lines or shapes, right? Some rectangles or circles or stuff like that. So yeah, so let me just show you how you can create one. So once again, we are importing tkinter, well, everything from tkinter, and we create a new window and then we show it. So right now we would like to create the canvas. So I'll just keep it like C will be equal to new instance of the canvas. So canvas, and inside here we pass few parameters. So the first one is basically the master. So once again, this will be placed in the window, all right? But then we can define two of the most important properties, which is width and height, all right? Right, what would you want in a canvas, right? You want to know how wide is it and how high and the height of the canvas, right? Nothing too much more. So inside here you can simply type width, and then you can assign to it, for example, 300 pixels, and then height, and let's do like 200, and yeah, and then what we want to do is basically show it. So I'll just pack it up. So pack, and yeah, in parentheses, and yeah, so let me just run this so that you can see that there is nothing too much to see. All right, there will be just a empty canvas, but we will draw shapes later on. All right, so as you can see, there is empty canvas. As you can see, the width of the window is wider than it is tall. All right, so that means this 300 is greater than 200, which makes sense, right? So right now, let me just create a new line. So how to create a new line and add it into the Canva? Well, it's actually quite simple. Simply type in here C, then dot, all right? And as you can see, if you type create, there are a few things that you can create, all right? You can create text, rectangle, polygon, a lot of stuff, all right? So let me start off with the simplest one, which is the line, all right? So as you can see inside here, you can create line with coordinates. So x1, x2, xn, right? And so on. So basically x1 and x1 and y1 is 1 point, all right? And that's the starting point. And then the xn and yn is another point, and that's the ending point, all right? So let's say that I want to create a line that starts at the top left corner and goes to the bottom right corner, all right? So how do I do that? Well, simply the starting point is 0 and 0, all right? And then the ending point is 300 and 200, all right? So y basically means the height, and x means the width, all right? So yeah, so let me just run this, and actually let me just add a fill to it. So fill, and let's set it to, for example, red, or something that we can see quite nicely. So if I run this, as you can see, there is the line, right? And it starts at the top left corner, so that means 0, 0, and it ends at the bottom right. So from this, you may notice that the height goes from 0 to 200. So down here is 200, up here is 0, all right? So in the middle is 100, and the width goes also from 0 to 300, all right? And inside here we have something like 150, all right? So 150. So yeah, that's the most important thing. You have the axis like this, basically, all right? So it's not like a mathematical graph or something like that. You basically, the y-axis grows down, all right? So yeah, let me also create another line. So create line, and let's say that we want to create this line that will go from the bottom left corner to the top right corner. So how do we do that? Well, the x-coordinate is in the left corner, right, will be 0. But the y-coordinate, that means the bottom, is 200, right? So bottom is 200, top is 0, and then we want to go to right, so that means 300, and top, so that means 0, all right? And let me just change the fill of this ones to, for example, green. And let's see how that looks. So if I run this application, as you can see, it goes from the bottom left corner to top right corner. All right, so this is probably the most important thing about Canvas. It's how you can index these points in there. And yeah, and then you can draw all kinds of shapes inside here. And we will draw more in following lectures. So if you have any questions, feel free to ask, and I'll see you next time. Alright, so in the previous lecture we talked about canvas. So in this lecture we will talk about rectangles. So rectangle is just a shape that you can place inside canvas, and it is defined by 2 points. Alright, so you might think that the rectangle needs 4 points, but since we have basically the other 2 points can be computed from the 2 points that you define. How is that possible? Well, you basically create a line. Alright, so you define a line, and the line will tell the 2 points, and the other 2 points will basically be computed via the line, alright? And yeah, so let me just show you how that works. So inside here I will just create a new rectangle, alright, and let's say that we will do pretty much the same thing as this line, alright? So if I run this application, what happens? Well, we get the canvas and it will be all red. Why is that? Well, the starting point basically means this point and in the top left corner, and it will grow down to the bottom right. Alright, so that's how we define a rectangle. And how do you compute from these 2 points the other 2 points? Well, basically the x coordinate from this one and the y coordinate from this one will give you this point, alright? The y coordinate from this one and the x coordinate from this one will give you this point, alright? So that's basically how you can define a rectangle only via 2 points, and that's what this create rectangle function does basically. And yeah, so let me just show you how we can define a different rectangle. So for example, this one will start at 100, alright, and it will go only to 200, and it will go from, let's say, we have like, so let's say like 80, and it will go to 120, alright? So this will be a kind of rectangle in the middle of the canvas, and as you can see, there it is. So how that works? Well, the starting point is at 180. So 100 on the x coordinate, that means we are in the 1/3, alright? And then 80 in the y coordinate, alright? So that means we are somewhere around like 1/4, I think. Yeah, no, something less than 1/3, right? Something more than 1/3. It pretty much doesn't matter, as you can see. Yeah, so this point is basically defined the first, and then the last, so that means this one, is defined as 200 and 120. So 200 basically means 2/3 of the x coordinate, and 120 basically means here, and yeah, it kind of fits, so that's quite cool, right? So let's create another rectangle. So inside here we will create a rectangle, and this one will be a bit wider, alright? So it will go from, let's say, 80 to, I don't know, let's keep the y coordinate same, alright? So this one will go to 20, and the y coordinate will be still the same, alright? So the y coordinates are same, but the x coordinate changes. So what do you think, how the rectangle will look like? So fill will be equal to, for example, green, and let's place this one in front of this one, alright? So if I run this, the rectangle will be behind this red rectangle, alright? So the green one will be behind this red rectangle, because the computer basically shows this rectangle, alright, and then he goes to the next line and shows this rectangle. So he basically placed this new rectangle over the rectangle that he previously shown. So what do you think? How the rectangle will look like? Will it be wider or taller? So yeah, it will be wider. Why is that? Well, we changed the x coordinate, and the x coordinate is basically right now the rectangle starts at 80, right? So we go from 0, and here is 80, and here is 100, alright? So it starts a bit sooner, and then it grows a bit more, right? So as you can see inside here, there are 220, that's here, and 200 is here, alright? So let me also change the rectangle so that it is taller. So how do we change that? Well, we need to change the y coordinate of these 2 points, and this one should be smaller. So for example, let's set it to 60, and this one should be bigger. But to demonstrate the changes, I will just make it less bigger, right? So this is bigger by 10, and this is smaller by 20. So if I run this application, it will look like this. So as you can see on top, there is more space, there is more green than on the bottom, right? And that is because we go from 60, so that means from here, alright? And then this red rectangle starts at 80, so that means somewhere in here. And then the red rectangle ends at 120, and then the green ends at 130. All right, so there is a bit less space. So yeah, that's basically how you can create rectangle. You can obviously place it anywhere you want, and that is pretty much it. So if you have any questions, feel free to ask, and I'll see you next time. Alright guys, in this lecture we will talk about how to create an oval. So that's quite simple. It's basically a rectangle, only it is like a circle basically. So if I type in here create, and inside here, as you can see, the oval, we can, for example, fit it inside this red rectangle. Alright, and we can make it, for example, white. So if I run this, as you can see, that's how the oval looks like basically. So it's nothing too complicated about this one. You basically just type you just create a rectangle, and then computer computes all the points he needs to create an oval from the rectangle that you just passed. So for example, if I want only a smaller one, I can simply put inside here, for example, from 140 to 160, and then from 90 to 110, and this will be quite small oval. It will look basically like a circle, and it does, right? As you can see, there's a circle. So that's how you can also create a circle. And another thing the oval is good for is to create really small points. So because in the TK Inter or in the canvas, there is no way to create just one point from just a point on a screen. For example, if you are drawing something, you want to just color up the points that you are clicking on, alright, so only single points. So how do you do that? Well, you do it via oval, but you basically do it like a really small oval. So if I do, I'm not sure whether you will be able to see this, but if I do like extremely small oval, so like this, and if I run this, there should be a white dot, and even I am not able to see this one almost. So yeah, there's like really, I can see it, but I'm quite sure you will not be able to see this. But if you run this on your computer, you should be able to see a really extremely small dot. It looks like a dot inside your application. And yeah, so that's how you can basically create a point via a oval. And that is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, in this lecture we will create the to-do list, so let's get into that. First of all, I will import, from the TK Inter, I will import everything, alright? And I will also create a new window, so this will be an instance of TK. And then I will basically display the window, so same stuff as before, nothing too interesting. But then what we want to do, well, first of all, what we can do is, for example, change the title of window. So I think I didn't talk about it, but you can change the title, obviously, of your window, and you can set it to something like to-do list. So like this, alright? And yeah, so that's how you change the title of your window. Now, let me define the main part of the application. So the application have a huge list box, then it have a one entry, and then two buttons at the bottom, right? So let me just define the list box. So let's call this one, for example, a content, and this will be just a list box, new instance of list box, which the master will be window. And then what we can define a lot of properties, but for example, I will change the font so that it is a lot bigger. So I can maybe do Arial. You can do obviously whatever font you want, same like colors. So I'll just keep it 24, and let's make it bold because this is the most important part of our application. Okay. So then what we need to do? Well, we need to create a new variable where we will keep track of the task that user wrote into the entry. Alright, so user writes something into the entry, we will store it into the task variable, and then we will add it to this list box, to this content, when he clicks on the add button. Alright, so As you may remember from previous lecture, the tasks need to be a instance of a string var, alright? And then we can create the new entry. So we can call it just E as a entry, right? You can obviously choose your own name. And yeah, so the master will be window, and then we need to define the most important property, which is the text variable, and this one will be the task, alright? And yeah, let's also make the font a bit bigger. So font, and this one will be also Arial, and let's make this like 24. Let's keep it same, only this time it won't be bold, alright? So yeah, so that's pretty much it. Then all we need to do is create these two buttons down there, right? So the button B, that, or for example button add, alright, that will be better. So this will be a new instance of a button, and the master will be the window, right? That makes sense. And then what do we want to define? Well, first of all, we want to define the text, and this will say add. And then what we need to define? Well, I will also change the font, because right now the font is quite small, and since we have big fonts on the entry and on the list box, the button would be extremely small, right? So I want to change the font also to, for example, Arial, and in here like 20. Alright, yeah, because the button have a padding, so it's okay to keep the font size a bit smaller. Alright, yeah. And another thing that I should define is the callback, right? So the command when the button is clicked. So what will be inside here? Well, I will just for now keep it blank, and I will get back to it, alright? So let's define also the delete button, and this one will be also a new instance of button. We will have a window, and the text will say just delete, so like this, and the font will be pretty much same, and I can also copy paste the command. And yeah, so right now let's take care of the most important part, which is the command. So what we want to do? Well, when we want to click, usually we want to call a function, right? But as you may remember from previous lecture, we have a lambda expression, which is just a simple function. And what we are actually doing when you click on the add button? Well, we just add whatever is in the task variable to the content, right? So that's not too much work. We could do it via one command, right? And yeah, so let's do that. So we'll define a new lambda expression. So we'll basically define a function here. We don't define the function somewhere in here, alright? And yeah, so this one will accept the content as a parameter, right? Which will be set to the content, to this content, alright? And yeah, and then it also accepts the task, right? We need to be able to get the task. So yeah, I will just call it task, and I will assign it to the task value, so to this variable. And what I want to do? Well, I would like to add the task to the content. And how do I do that? Well, I simply type in here content dot insert, alright? And this will basically insert some string into the list box, alright? And first of all, we need to define the index where we want to put it, and we want to put it at the end. But how do we know the end of the content of this instance? Well, we simply type in here end, and computer will take care of everything for us, alright? So then all we need to do is simply type get the text from the task variable. So in order to do that, we simply type task.get, and this will return the text that is written into the entry, alright? And yeah, so that's basically the add button taken care of. It's quite simple actually. And yeah, another thing that we can do is define the delete button. Well, not only can, but will do. So pretty much same thing in here. So we will basically take the lambda expression as a function, alright, because we only need to delete something. So that's not too complicated. And what we need? Well, we actually need only the list box, right? Okay, so I'll just call it content, and I will assign it to the content, so basically to this variable. All right, so this variable will be binded as a content inside this lambda expression, and then all I need to do is simply type in here content dot delete, and inside here what do we want? Well, we want to delete the element that is selected. All right, so the idea is that user clicks and it deletes the selected item, but how do we know which one is selected? Well, simply via this anchor. All right, so in here basically computer, if you type in here anchor, computer knows that he needs to take care of the selected one. And yeah, so that's about it. Right now all we need to do is basically place these elements somewhere in our window. So that's not too complicated. If you feel like you can get the last part going all by yourself, it's a good thing if you try to pause the video and try to do it on your own. All right, so yeah, so simply type in here the content.grid, and we'll place it to the top, right? So the row will be 0, so the row will be 0, and the column will be also 0, right? And then what we need, well, we need the column span. So column span, so that means basically that this element will be in 2 columns together, right? So basically 2 columns, and yeah, because we will have like this whole list box, then underneath will be also the entry. This will also take 2 cells, and then there will be one button in one cell and other button in other cell, but these buttons will be on a same line. All right, so yeah, so this will be 2. All right, so because we want 2 cells, and yeah, then we can also define something like padding. So padding of X will be, for example, 5 pixels, and padding of Y will be, for example, 10. All right, and yeah, so that's basically the list box taken care of. Right now all we need to do is place the entry, so e.grid, and inside here we want it to be on the row 1, so directly underneath this content. And yeah, the column will be also 0, right, because we want it as left as possible. And then what we want to do is also add the column span and these 2. So I'll just copy paste it to save some time. And yeah, so then all we need to do is place these 2 buttons, the add and delete button. So add.grid, and inside here we will have the row 2. So this will be underneath the entry. All right, and the column will be 0. So column will be 0. And then what we also need, well, we can define the padding for this. Yeah, let's define the padding for it so that these elements are not tied up together and they have a bit of space. All right, so for example, the X can be 5 and the Y, let's make it a bit bigger. All right, and yeah, same goes for the delete button. So I'll just copy paste it. So inside here will be the delete. And what we want to change for the delete button, well, the button should be on the right side. All right, so we will change the column from 0 to 1. Okay, and that should be it. So if I try to run this application, as you can see, it looks quite good. Well, reasonably good. These buttons look terrible, but yeah, if I type in here something, whatever, and hit this add button, as you can see, there is the task, and something else is also added. So cool. And yeah, so what I can also do is delete something, so I can select it and then delete. Cool, that also works, right? So yeah, that's basically working application. Right now the add button though looks quite odd, since the delete button is a lot bigger, a lot wider, right? So let's also add some padding to this button. So in order to do that, we can simply go back to our editor and find the add button that's right here, and we can add the padding. So padding on the X coordinate. All right, so we want to change the width, and we would like to add, for example, 30 on each side. Alright, so 30, and let's see how that looks. So if I run the application, I get an error. Alright, I forgot about comma inside here, and if I run this again, it should work. Yeah, it does. And as you can see, the button is a bit bigger. Alright, so they look pretty much the same width. So yeah, that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, in this lecture we will create the text editor. So let's get started. Simply, first of all, let's import everything from the tkinter. So from tkinter, import everything. Alright, and let's also create a new window. So window will be equal to the new instance of tk, and let's show it. So same stuff as before. Yeah, you probably know. And yeah, so another thing that we want to do is define the menu on the top. Alright, so simply create a new instance of menu, which will be the main menu. Alright, so this is a new instance of menu. The master will be window. Alright, and yeah, so then we also need to config. So window.config, config the menu. Alright, so config, and inside here we type menu and we set it to the main menu, right? So main menu like this. And yeah, I wrote comments. Yeah, so like this. And another thing that we need to define is the submenu, right? So we will have a file in there, and when the user clicks on that, there will be like save, open, and stuff like that. So we define a file menu. So this will be also a new instance of menu, but the parent will be main menu like this. And yeah, and we will basically add it to the main menu. So main menu dot add cascade, and we add there the label, which will be the file, and we also pass in there the menu. So menu, and this will be the file menu like this. And cool. So right now let's add some stuff to the file menu. So file menu dot add command, and what do we want to add? Well, we would like to add the, well, first of all, probably the open, right? Open is the first one, I think, always. And the command will be, for example, just open file. So this will be just a function that we will define later on, alright? And then we will also add file menu dot add command, and this will say save. Alright, so label equals save, and the command will say something like save file. Alright, so these are functions that we will define later on. Alright, so let's also add the separator. So file menu dot add separator, so dot add separator, and let's also add a, I don't know, for example, close. Well, I don't want to program functionality to all of these, but yeah, so just so that it looks a bit professional. Alright, so I will just add the last one, which will say close. I believe that this is the menu that you have in pretty much every application. Oh my god, I cannot type. So this one and this one. Alright, and yeah, so you can obviously add another thing like edit or stuff like that. I will just, for example, add another one. So for example, main menu dot add just a command, something like help or whatever. Yeah, you can do whatever you want. So I'll just add the label help. Cool. And yeah, so then what do we also need? Well, we also need the huge text box in which the user can see the file and write into the file, right? So how do we define that? Well, it's quite simple actually. We can simply name it somehow. So for example, content, and this will be just a new instance of text object from the tkinter, and this is basically a huge text box in which user can write. So it will be placed inside the window, and we can also define the width of this whole text area, which will be, for example, let's say that it will be 100. All right, so 100 characters basically. And yeah, so let's also display this. So content.grid, and this one will be, for example, row 0 and column 0. So column 0, and let's also add the padding. So padding on X, let's say 5 pixels, and padding on Y will be also 5. Cool. So if I try to run this right now, we will get an error because I didn't specify these functions, right? But yeah, so that's pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so in this lecture we'll program the functionality of this application. So this one will be a bit more interesting. And yeah, so let's get into it. First of all, let me just import, well, no, we'll do that later on, alright? So first of all, let me define the function. So for example, first one will be the open file. So this accepts no parameters, and what we want to do? Well, we would like to ask user for a file. So we would like to open the open file dialog, right? So the dialog that opens up, user simply selects a file and he loads it. So how do we create that? Well, we can simply do that using the file dialog from the tkinter, alright? So we will import from the tkinter, we will import the file dialog. This one is not imported where the star, alright, you have to explicitly import it like I do right here, alright, and this will basically allows us to use the file dialogs that are defined. So then what we can do is simply type in here the file dialog dot, and inside here is the ask open file, alright, so ask open file, and this will basically open the dialog for you. So first of all, you need to define the mode, which will be read, right, R, and then you can define, for example, a title of the window, so title, which will be, for example, open or select file, and then what we can do is also define the file types. So for example, file types, so this one is extremely important. For example, if you are working with, I don't know, images or something like that, you probably want to define the file types that are allowed, right? So let me just put it on the next line, and the file types is basically a list, alright, a list of all the tuples that you can have, alright? So inside here you type the first one is basically what it says, so all files, for example, and then you can import everything. And how do you import everything? You can do it like this, so star dot star, alright, that means basically every file possible. You can also import, for example, only text file, you can import, right, you can change. So this is basically what is shown in the dialog, and this is basically the extension that is needed, alright, but I'll just open everything, whatever. And yeah, so this will basically open a file for us, alright, so then we will have in the T, we will have the file that we just opened. And then what we want to do, well, we would like to set it to this content, right? So to this content element. So how do we do that? Well, the content have a method that is defined exactly to do that, and it is the insert method, and it takes a few parameters. So the first one is basically the index where we want to put our text. So for example, to the end. And then is the actual text that we want to add, so that will basically be the t.read, alright, so we will read everything from the file that we just opened and put it to the end of our content, alright. But I think that's pretty much it. So right now let's also close the file, alright, so for yeah, and we will just hope for now that the file will exist and everything will work. But yeah, then we will take care of the exceptions. So if I run this, alright, and we get an error that the save file is not defined, so I'll just basically take it out, and also this comma, and if I run this again, the application is shown, and if I click on file, and then I click on open, it automatically asks me to select some file to open, right? So that's quite cool. And as you can see in here is the all files, right? So that's basically what we defined in here, so the file types. And there, so for example, if I select something, it works. It works. That's the file that we just opened. And yeah, so right now we can edit it out. We can do all kinds of stuff inside here. We can write, we can do whatever, but we cannot save. So how do we fix that? How do we save the file? Well, it's quite simple actually. First of all, let me just put back the command for the save. So command will be save file. So save file, and let's define the method or function that does that. So inside here, I will just define the save file method, and it will basically just accept nothing. And what it will do, well, it will once again open a file dialog. So file dialog, and it will ask to save the file. So ask save file. All right. And the mode will be write, because we want to write it, right? And the extension, so we can define a default extension. So default extension, and this one will be, for example, the txt. All right, so that's txt. And yeah, so then it basically opens up the file. And what we want to do, well, we would like to write into it. So we will basically like to do f.write. And inside here, we would like to take all the content from the content, right, from this element. So how do we do that? Let me just first define the variable before. So I will do it separately. So inside here, I will basically type the text user road. All right, and we will get the text from content. And how do we do that? Well, we will simply take the content, then get. All right, so get. And what do we want to get? Well, we would like to get everything. And as you can see inside here, it basically takes two indexes. So from index 1 to index 2. And the index 1 is basically, we want the starting position, which is 1.0, all right? And the index 2 is the end, all right? So the index 2 is the end. So simply type in here the end. And we also need to change it to string, all right? So string, and put this into parentheses, all right? So right now we have in the text user road, in this variable, we have the actual content of the window, right, of the text. And yeah, so right now we can simply just write it. So text user road, and we write it into the file. And then we close the file. So file dot close, like this. And let me run the application. So if I click on the save, even though I didn't write anything, we get an error. Okay, so what does it say? So if I just close the application, it says, all right, file, blah, 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 what happens in here? Save as, all right. Options must be default extension. All right, I made a typo, sorry about it. Extension. So if I run this again, and I type something in here, so for example, some nonsense, and hit the save, it opens up a dialog, so that's quite cool. And right now I can save something, so for example, my saved file, like this. And if I save it, so if I save it, as you can see, it is in here, all right? And when I click on that, it actually opened the content of the text box that we have in our application. So yeah, that's also working. So that's quite cool. So this is pretty much it for this lecture. If you have any questions, feel free to ask, and I'll see you next time. Alright, so I almost forgot on the close. So let's also make it work. So inside here we will type the command, and we will assign to it something like close window. Alright. And yeah, so let's also define this, and this one is quite simple. So inside here, for example, we can define a new function called close window, like this. It will accept no parameters, and what we want to do, well, we would like to close the window. And in order to do that, it's actually quite simple. You type just window and then destroy, all right, and empty parentheses, and it will basically just close the window for you. All right. And another thing that I want to do in this lecture is basically take care of all the problems that can occur when we are working with these files, right? So sometimes can happen, for example, with the save file dialog, that the user, I don't know, just clicks on the cancel, right? So doesn't save the file. So first of all, we will check whether the file is existing. So whether if it is actually existing, or more or less whether it is not existing. So if it is none, that means the user just somehow canceled this dialog, alright? So this dialog that's being shown, he hit the cancel. So what is stored in this variable? Well, it is just none. So we check whether the file is none, and if it is none, we simply return from this function, alright? So we will not execute all of this code down below, alright? And yeah, so you can also return from a function without any value, alright? I'm not sure whether I mentioned it before, but I'm mentioning it now. So this is basically just, hey, I'm done. This is just exactly like the break statement, alright? And yeah, so then there can be some errors occurring in here, right? So we'll just for sure, we will just put it into the try statement. So we will try all of those, alright? So both of these. And then we will do the accept. So accept, and if something happens, we will just, for example, print, I don't know, cannot save the file, alright? And finally, we will just close the file, alright? So finally, we will just close the file like this. And yeah, so that's about it. That's about it, because right now we don't have to check whether the file is existing, because if it was not, we would return at this point, alright? So this code would not be executed. So that's alright, that's just fine. And yeah, so let's also put these things into try and catch and accept, sorry. So how do we do that? Well, inside here we can just put everything in try. So try, and inside here we will basically put both of these lines into the try statement, alright? And then we will simply do the accept. So accept, and if something goes wrong, which can happen, we will just print cannot load the file, alright? And yeah, and finally we will just close the file. So finally, well, we will not just close the file, we will first of all check whether the file exists, and we can do it just like this, and then we can close it, so just like that. And yeah, alright, so this will basically take care of the checking whether the file is actually existing, because sometimes can happen that the user, I know that the file just doesn't open for some reason, something goes wrong, alright, and the T is just nothing. So we check whether the T exists. If it does, we will just close the file. And yeah, so that's about it for this lecture. If you have any questions, the application is just right now working. Everything is working except for the help, but I'm not sure what to do with the help. But yeah, so that's pretty much it. If you have any questions, feel free to ask, and I'll see you next time. Well, hello guys, and welcome to this lecture. In this lecture we will create the paint, so let's get into it. So first of all, we will import, well, from the tk-inter we will import everything, and then what we want to do, well, create a new window. So this will be just a new instance of tk. Then we also want to show the window, so main loop like this, and inside here we also want to create the canvas in which we will draw, so canvas, and this will be a new instance of canvas like this. And as a master will be the window, and the width and height is up to you. I'll just keep it, for example, at 400, and the height will be also about 400. And yeah, so then I will just pack the canvas, so pack, and yeah, I will not specify where I want to pack them. There will be only canvas in this window, alright? And yeah, so another thing that we need to do is define a event for the canvas. So how do we do that? Well, first of all, we need to bind the event. So basically the canvas allows us to bind some different events, like for example when user clicks we can do something, but when user, I don't know, holds a mouse, right, holds the left button on your mouse and simply somehow do some motion over the canvas, we can also bind an event to that. We can also bind an event to different buttons, right? And yeah, so how do we do that? The most important thing is the bind method. So the bind method basically accepts a string which will define what event we want to bind. So for example, a string like this, so for example like this, button 1 will basically bind the event that user clicks via the left button, alright? And the button 2 is for the middle button, and the button 3 is for the right button. So for example, like this would be for the middle button, and this would be for the right button, alright? But I'll just keep it for the left button. And then what we also do is define a callback. So basically a function that will be called. So inside I will just call it callback. And right now let me also define the function. So define the callback. And this one will take some arguments. And what are the arguments? Well, what do you think is the argument of a mouse click? Well, where the mouse clicked, right? So some coordinates, some x and y coordinates of the mouse click. So inside here, I will simply type in here the event, and yeah, and then what we will do is simply print the coordinates. So event.x and then event.y. And if I run this application, as you can see, a window shows up, and if I click somewhere, right? So I'm clicking somewhere in the application, and as you can see, it tells me a coordinate. So inside here is the 4 and 4, so that means somewhere in the top left corner, as you can see, there are small numbers, and inside here will be the big numbers, alright? So 400 is the width of our canvas, and yeah, so as you can see down here are some big coordinates. And right now we can use the callback to basically create a drawing. So what happens if we, for example, draw a point via the over somewhere where the user clicked? So we can do that, right? Inside here we basically have the coordinates, and if we want to draw a over, we simply need these coordinates. And yeah, so let me just draw it. So we will take the canvas, so C, and inside here we will create a new over, alright? And let's make it a bit bigger. So event.x. So the starting point will be, for example, -5, alright? So the oval will be quite big, alright? And the ending point, so event.y, will be also sorry, that's the y coordinate of a starting point still, alright? And then the ending point will be in the event plus dot x, alright? So the x coordinate of the ending point will be a 5 pixels bigger, and the y coordinate will be the same. So event dot y will be also +5. And we can also define the fill, and this can be green, or I don't know, it can be also, another thing I forgot to mention is that you can use a RGB model. So simply inside here type hashtag, and then you can type some color in RGB. So for example like this one or whatever. So if I run the application right now and click somewhere, as you can see there is a point, right? So I can just click, I can do quite simple stuff, some simple clicking, and I can draw, I don't know what I can draw, but yeah. So that's how you can create a simple callback that will basically print the event. So if I just move it like this so that you can see it, and let me just get rid of this stuff. So what we can also do is create a callback that will basically take care of the motion. So for example, when we click and keep the button clicked and move around the canvas, the motion will basically detect that, and each time we move it will call the callback and with the position of the movement, alright? So how do we do that? Well, we will basically bind another event. So the motion movement is simply like this. So inside here you type the button, so for example button 1, and then motion, like this, alright? And inside here it could be also button 2 and button 3, depending on what button you want. So the button 3 is the right, and the button 2 is the middle button, but I want the left one. And inside here you can define the callback. So for example, draw, yeah, just draw, and inside here I will define it. So define the draw, and inside we will take the event. And what we want to do, well, each time we draw something, we would like to pretty much do the same, right? So we will basically add a new oval into the canvas, and yeah, and let's maybe keep this one, for example, or I will just keep it same way, but I'll just change this one to, for example, FF. Let's make it white, or no, let's make it black. 1 2 1 2, so like this. And so this is basically black. The FF would be white. So yeah, so let me also print the coordinate of this function so that you can actually see this. So print the event X and the event Y. So like this and like this. And I'll also get rid of all of these points that we already printed via the clear. And if I run this, we can see the window. So if I click, this callback gets to be called. And if I click and draw, as you can see, there is the motion, and I can basically draw whatever I want. Only I have to draw it slowly, because if I suddenly like do some quick movement, the computer is not fast enough to basically call the function each time. Because the movement is so fast, right? So yeah, and still if I click, I get a different, right? So that's another thing. And what you can do is, for example, create a rectangle inside here on a click or whatever, right? Or with the left mouse you can create a rectangle. So with the left mouse, let's actually do that. So c.bind, and inside here we want to bind the left mouse movement. So it will be basically be free, and inside here it will be just a motion. Alright, so like this. And what we want to do is draw a rectangle. So like this. And how do we define that? Well, simply type in here draw rectangle, and it will accept a event. So event. And what we want to do, well, we would like to simply, I will just get rid of this print, and we would like to just create a new rectangle. And these coordinates should be, well, actually we need the first coordinate and the last coordinate. So the motion is not quite good for this. We would rather take the click, right? So we would like to take the first click and then the second click, and if there is already a first click, we would like to draw a rectangle. So yeah, let's do that. This one will be a bit more complicated. So anyway, we can do that. So for example, on the button free click, so that means on the left button click, we will call this function, and inside here we will basically define a boolean. So up here we will define a new boolean variable whether we want to draw, alright, and by default it will be set to false. So by default we only want to take the first point and don't draw anything. And if it is true, we would like to draw from the first point to the second point. So inside here I will also keep the x1 and the y1. Alright, so y1. And this will be the starting point. So the idea is that you click with your left button once, then you will set the starting point, so these two, and then you click for the second time, and it will draw a rectangle from this starting point to the point where you clicked for the second time. Alright, so yeah, let's do that. So inside here we will first of all check whether the draw is false. So if draw is true, what we want to do, we would like to create the rectangle. So c.create rectangle, and inside here where we want to start, well, we would like to start at x1 and y1, alright, and then we would like to draw it to the event coordinates, right? So the event.x and the event.y. So this is our ending point, so the point where we clicked. And we can also change the fill. So for example, the fill can be just, I don't know, red, alright? And yeah, so but if we And if the draw is false, so by default it is false, what we need to do? Well, that means this is the first click. So we need to set these x1 and y1 and set the draw to true. So the x1 will be equal to event.x and the y1 will be equal to event.y. And then we need to set the draw to true. Alright, so if I run the application, as you can see, it takes a while to compile. But as you can see, if I left click somewhere inside here, okay, I get an error, draw variable before. Alright, I'm sorry, I made a mistake. So inside here, what is happening? Well, we basically are using the draw variable and the x1 and the x2. X1 and the y1. But these are global variables, alright? So we need to tell the function that. Hey, the draw and the x1 and the y1 is basically a global variable. So inside here, we will tell that. So global draw, then x1 and the y1. So like this. So that basically means that the x1 and the y1 will be referenced from here and the draw also, alright? But yeah, so right now this should work. So if I run this again and left click somewhere and then left click again, I get an error. Alright, I made a mistake in here, so I meant to say y1. So for the last time, if I run this again and do a left click and another left click, as you can see there is a rectangle appearing, alright, but yeah, then we get an bug because right now when I clicked, it just creates new and new rectangles. Alright, so what I want to do is basically after I draw the rectangle, I need to set the draw to false. Alright, so that we can then define a new rectangle that we want to draw. So if I run this application again, hopefully for the last time, and I do left click and another left click, that's cool. And right now I do another and another, yeah, that works. But as you may notice, you cannot draw lines. So if I'm trying right now to draw a line, but it doesn't work. So why is that? Well, inside here, you simply need to put this one above. So there's the problem that we have these callbacks right after and then we somehow defined a variable. So that's a problem. So if I run this right now, and hopefully for the last time, everything should work. So if I create a new rectangle, that does work, cool. And if I create dots, that also worked, but somehow I clicked somewhere out of the window. I can also draw lines.